Okay. Hey, everyone. How's everybody doing today? Great. Awesome. Hey, if you can find your seats, we're going to go ahead and get started here in about 37 seconds. Who's excited to be in person? Clap if you're excited. Come on, I'm excited to be in person. Yeah, clap if you're tired of trying to find that mute button. Yeah. Woo, I am too. Okay. All right. Hey, so good morning. My name's Nick Rinaldi. I am the one of the planners for Vertex Energy. I'm with the Army Applications Lab here for Army Futures Command headquarters here in Austin. So really excited to have you all. We have a great event planned for the next couple of days. So I hope you're excited. If you kind of look left and right, like there's not a whole lot of in-person things that we've done recently. So I know this is exciting. And I would say probably every person you see here, kind of left and right, they're an interesting person, right? We vetted folks to come here. We wanted to make sure the right folks were in the room. And so it's an exciting opportunity to meet someone today. Just real quick before we get started, I do want to kind of remind folks kind of what we're doing here today. And then I'll absolutely introduce some folks that have some opening comments as well. Just for some of the industry and academia in the room, the Army does these kind of activities a lot. Industry engagement, it's pretty often. So rarely, though, do you see a group of folks from our requirements writers, our S&T subject matter experts, our acquisitions folks that are kind of responsible for the larger fielding of equipment in the Army. Rarely do you see them all in one spot. So there's a great opportunity here to speak once and efficiently let everyone hear you. I think that's an awesome thing to have to keep in mind. For the Army, I think there's there's a lot of people that wanted to come to this that's not in the DoD that wanted to inform and be a part of this community, and only 150 got to come. So every person you meet here, I think, is an interesting person. You should get to know them, meet someone you don't know, and then pick their brains, because I guarantee that there's some very high. I'm probably the dumbest person in this room right now, so just something to keep in mind. We do have an opportunity here to be a little less transactional as an Army when we work with commercial folks, as we work with our academia. And I just think it's another opportunity here to do that better, to do it well, to continue to kind of work to close the gap, between the U.S. military and the commercial world. That's something that I think that has really driven this event to its kind of fruition here today and over the next couple of days. So excited to have you. I do want to thank a couple folks up front. 75th Innovation Command has been a huge help in making sure we find the right folks to come today across industry and academia. UT Austin assisted a lot with moderators for your breakout sessions, and there's also participants today from them as well. And then Capital Factory here, we're in Capital Factory in this venue and upstairs as well, and across the breakouts today. So thanks to those folks for helping us get that squared away. There's a lot of AFC staff and stakeholders, along with Army Applications Lab, that helped put this thing together, and they're in the audience today as well. So thanks so much for making sure this happens well. A couple quick admin notes. Safety. So we've got these like 4x6, the biggest badges you've ever seen on your chest today. Please wear them, and you should have like a wristband too for each day, and that just helps our staff identify that you're supposed to be here. This is an exclusive event, so we want you to be in person, make sure that you're part of the team. If there's like a fire or something crazy that happens, there are 4 big exits that go outside of here from the Omni Hotel. Please use them. And if there's a problem, something doesn't quite look right, please find one of us. For Capital Factory staff and Applications Lab folks, if you can just like raise your hand really quickly. There's a couple of people back there as well. So like those are folks that'll help you if you have a question, you have a problem, concern, okay? Okay, promise, last thing. On the backs of your chairs, sorry for folks in front, backs of your chairs, there's a QR code, and that's how we're gonna do Q&A for all of our panels. So make sure that QR code works. You're gonna be typing it in because folks on the first and 8th floor are gonna be pumping questions in during those panels and keynotes. So that's just what that QR code is for, and that's how we'll do some Q&A. Okay, I'm done talking. I'm going to introduce Brigadier General Michelle Letcher. She's our Chief of Staff for Army Futures Command. She's a logistician by trade, has a lot of experience in the European theater, so I know sustainment and energy is like near and dear to her heart as well. So without further ado, Brigadier General Michelle Letcher.
Thanks, Nick. Good morning. A lot of energy in here, right? I'm sure there's a joke in there. If I was more clever, I would come up with one. Any baseball fans in here? Oh, the energy just went down, right? Especially when somebody sounded off being a Cardinal fan. I almost had to leave. I'm a Cubs fan, but tonight I'm headed to the UT Austin game, and I was trying to like color code a little bit. And then as I walked out of the house, my husband said I looked like I was going to an Auburn game, so I clearly did not do well. But I bring up baseball because I was just talking to Jonathan, who's sharing with me that he can carry a tune. So when he gets up here, you may want him to sing a little bit. But he was talking about what his hype song might be, which kind of brought me back to baseball because do you know what a closer song is? What? They got a song, right? What's your closer song like when you're going out to do something really awesome and it's playing in your head? Well, mine's not Sweet Home Alabama, so it's hard to kind of judge that, but who's got a really good hype song? I heard it, what? All right, they're Metallica. That's good. This is the closing playlist, Nick. You better take this down. Anyone else? So none of you have any music in your head, right? It's always energy, 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 which I guess is good for what we're doing today. AC/DC, there, that's very not country, but I appreciate you throwing that out. Oh, wait, did you say AC/DC? Was that? Yeah, good. Well, good. All right, Maria, what's yours? All right, well, that's a good one too, right? Okay, well, good. Well, good morning, and thank you all for coming to this event for for Vertex Energy. As Nick kind of said, we're here to work collectively together so we can kind of solve Army, but not really Army, our nation's like, challenges. As he talked, I have a lot of experience in Europe, spent a lot of time in Eastern Europe. When I took battalion command, we were all high-fiving because tanks went home, right? And then I came back in 2015 and Crimea had been annexed. And how we think about energy, how we think about distribution, how we think about the theater has changed completely in just a couple of years. And so what's really important about this event is that we have a problem, right? Not just the Department of the Army, Department of Defense, our nation. And then collectively here, we have solutions and ways to bring that forward. And so what I think is really powerful about this event is that we're going to kind of bring the ecosystem together and collaborate. I think we have 12 use cases, right, over 3 days, multiple panels, multiple opportunities for people to kind of share and collaborate. Also during this week, you're going to meet a couple of my bosses because we wouldn't be an Army organization if we didn't have lots of leaders, right? So we have 4 3-star equivalents. One is the acting CG, acting commanding general, and that's Lieutenant General Richardson. He will be here, I think, tomorrow. Over the next couple of days, you'll all get to meet him. And then he is kind of our CEO, if I could put his job into, commercial speak. And then you'll also meet Lieutenant General Thomas Todd, and he's our Chief Technology Officer. And both of them will come and spend a little bit of time with you. You'll have an opportunity to speak with them and kind of share some of your ideas and the outputs of what those use cases look like. Before I kind of turn it back over to Nick, I just want to highlight how really important this is. And I know people get frustrated with government because we can be a very bureaucratic organization. And so it's really important for us to understand from you how we can make it less of that and deliver capabilities much faster to the end user, which is our soldier. When we stood up Army Futures Command, really our goal was that we could get requirements out a lot faster, get soldier touch points through the process so we understand what the end user needs, right? Which is how you do it in the commercial world, right? In the military, we like to say, we need this capability, develop it, build it out years later, hand it to a soldier, and it's not what the soldier needs at all. So this command was stood up so we could iterate much more quickly to get the soldier what they need. And we're listening to others. It's not just people in uniform, but it's people who have experience in fields like this in energy to help us deliver that. And so I'm really grateful for the opportunity to open this up today, talk a little bit about baseball, to talk a little bit about hype songs and closer songs, but more importantly, about how important this is, not just to the Army, but to our national security, because it really is collectively all of us that deliver that. We're just one aspect of it, and we really appreciate what each of you do to kind of help to deliver to that end. And so have fun, tell lots of energy jokes, Nick, and if y'all think of any really good closer songs, let's put that playlist together. Have a great week. And if there's anything I can do for you, Nick has my email. I don't think there's a QR code for me, but we can develop one of those as well. And just reach out. I'm on LinkedIn as well. I look forward to what you're all going to come up with, what we're going to come up with together. So thank you. Tomorrow's worth protecting.
Okay. Hey, fantastic. And we have one more person that definitely wants to welcome you all. And he is taking on quite and a lot of folks know him in this room too. Lieutenant Colonel John Vilsenor. He is one of the leads for our Army Operational Energy Strategy. And he's sharing some things with you today, trying to be a little bit more transparent with the folks in this room and online, right? There's pamphlets as well in the back for where they're at on their strategy. And it's just helps frame maybe where we are, big picture from Army Operational Energy Strategy. So please, round of applause for Lieutenant Colonel Vilsenor.
Thanks, Nick. General Letcher, distinguished guests, friends, family, industry partners, Dean McGrew. Thank you for the opportunity to take a few minutes to discuss the Army Operational Energy Strategy. My name is Lieutenant Colonel John Vilsenor. I'm one of three that have been tasked to write the strategy. With me here today is Major Jesse Sheehan, Mr. Jim Eaton. We come out of Mass D, FID, FCC. And we've been the facilitator for a series of working groups with the goal of publishing the energy strategy fourth quarter, no later than fourth quarter FY, this FY. With me also, and as we go through the Q&A later, as you see me in the hallways, there are also a series of subject matter experts that if you can't get me or one of the two that I've mentioned, I would be remiss to also or not mention Ryan Ressler out of MCDID, Josh Simmelsick out of SCDID, and Bruce Guile out of DevCom ARL. These three have been with us since Jump Street, so at SP, at LD, they've been with us, and they've been kind of going through all the March objectives with us. So if you catch one of those subject matter experts, it's worth your time. They also represent about 70 to 80 individuals representing or working for over 20 to 25 organizations and agencies across the Army modernization enterprise. This work group is dedicated to publishing the strategy, which then lays out where the Army wants to go in terms of energy transformation and modernization in the near term up to 2030, midterm 2040, and then beyond. It's a huge task. And the breadth and depth that we've had to accumulate over the last 6 to 8 months is astronomical. And when first tasked with this, the questions very quickly became, is anybody even working this? And through the conversations, through the working group, and then through conferences like this, what I've come to realize is that we are in a better place. We are in an okay place for the United States to move forward and to fight and win in future conflicts. I'm going to give you guys some context. Some of it will be very pedestrian. I understand, just bear with me because it gives you an idea of how the group is seeing the fight and how the strategy is being drafted. So coming out of two conflicts, right? We've had to project combat power and sustain that combat power from the United States in the Middle East. A very daunting task, and one I did not appreciate, even though I served in both of those theaters. So in order to set the theater, to push the amount of supplies across all classes, and to sustain those soldiers that were disaggregated across thousands of patrol bases, combat outposts, and major FOBs, again, I did not appreciate it at the time. And now that I'm starting to look at it, it's one of those where, you know, I'm sure books, white papers, and case studies will be written about it because we did it very effectively. Part of the problem, though, as we came into those theaters, was we started to kind of AAR that sustainment and logistic execution of that operation. And some of the things that we started to discover was lines of communication, right? So extended lines of communication are extremely vulnerable to attack and disruption. And if that supply is needed or required and they don't receive it, you know, you're looking at mission failure at the far end. You're also looking at 48% of the fuel that we used in both of those theaters were outsourced. So we asked the sovereign state to supply it. We pushed that lines of communication through multiple sovereign states in order to get the fuel we required or the class of supplies we required in theater. Logistics footprints. Yeah. Battlefield logistics, we started to understand that very large footprints, logistic footprints, may or may not be conducive to future conflicts. So I have a large formation to include TSC setting the theater. I have large logistics formations securing and transporting those classes of supplies. And they're at, 90% of the time they're static. And if you served forward, those places were targeted by missile and mortar attack constantly. So again, future conflict, peer near peer, would those static positions survive? And then the amount of resources, right, required to push that, and that's across maritime, air, and land. Was it the most efficient? So I'm actually I'm burning energy to transport energy in order to burn energy. So kind of like some of the things, and again, very pedestrian. I'm sure if Josh was up here, he'd be able to explain it a little deeper about the sustainment issues coming out of those two theaters. What we're seeing now, so a contemporary case study, is the Russian conflict with Ukraine. We projected from CONUS across the planet. They are projecting in the next sovereign state. And the information that you can see on open source is that they're not doing it extremely well. And it's because you have a missile threat, you have a disaggregated formation, Ukrainians fighting them. So it's become quite a battle of attrition. And they're targeting their lines of communication. So their ability to sustain their combat power is being attrited. So most of you are familiar with the current Army operating concept, so multi-domain operations. It tells me pretty much that I have to fight land, air, sea, cyber, and space. And if you talk to the G2s of the world, they're going to say anywhere, anytime, against any threat. Then you have the anti-access area denial capabilities. These will only get better as the extended ranges and more lethality continues to proliferate to our non-state and state actors, especially if they have a common cause. And then the bottom right, forward line of troops will no longer exist, right? So against peer near peer, there'll be a lot of attrition, extremely lethal. But what we'll see is that our tactical and operational support areas will be targeted as well, not only through long precision fire missiles, but through special operations and guerrilla tactics through Army formations that have disaggregated down to company and battalion sizes moving through the rear areas. And then operating environment. This is probably where it gets the most complicated for the Army. So if you ask a G2 right now, where are we going to fight? It's everywhere. I'm going to fight in the Folded Gap again. I'm going to fight in the Indo-PACOM islands. And so when you term it or you phrase it that way, it's very hard to drive a requirement or a gap that allows me to kind of go after that, because you can't tell me I have to fight everything anywhere. That becomes very complicated when you try to resource that. So that's kind of like the environment that we currently find ourselves as the Army starts to transform and modernize, and it starts to look at the future threats. And then so in order to survive in this environment, based on the two theaters, some of the lessons learned, and kind of like defining what that operating environment looks like. What does that formation in the future, a U.S. formation, look like? It will probably have to fight disaggregated. A large battalion formation with a tactical alpha will probably be targeted and destroyed based on the lethality capabilities of our enemy. So we'll have to break that apart. When I break that apart, there's a lot of things that we'll have to modernize as well. My sustainment infrastructure has to be able to adapt to that ability to support what I would consider like a giant spider web, right? Where units are operating very small, and I still have to give them their classes of supplies. Mission command nodes. My ability to signal and to push RF will be targeted. So now we're asking those disaggregated small units that are not tied to a line of communication to operate independently, right? They're given their task and intent and they're moving out, because if they broadcast, they're going to be targeted. And so now I'm on an environment with ubiquitous sensors, right? That are giving offensive and defensive capabilities, the ability to target, acquire, and destroy me. So now I'm constantly on the move. Or my technology has gotten so good that I'm able to mask or camouflage myself. So that's a lot. And the strategy is trying to approach that given that context. Some of you have probably seen this. We stole this in DevCom. So in the lower left, you have ground vehicles and aerial vehicles and autonomous systems. We understand that our ability to extend operational reach and endurance provides that warfighter of the future, the lethality. That vehicle also has to be able to provide power, distributed power. Probably has to help them with managing that power. And that's a lot for that platform to do. And we also understand that in terms of signature management, we're going to have to transition off of fossil fuels, because that's the biggest piece of the line of communication right now is pushing JP8 to all these combustible engines that consume it. And so as we start to look at this, again, I thought this was an easy thing to do, because if the chief of staff of the Army said, John, I want to go to electric vehicles tomorrow, well, sir, it's easy. It's called Tesla, right? We just buy a ton of Teslas. And the engineers over at Tesla would be, we'd go to the car lot and we start picking out the Tesla and we say, hey, we need a truck. He says, we got one. I'll be like, awesome. Hey, it needs to carry 12 dudes. Or, I apologize, men and women. And he would be like, ooh, that's troublesome. And I'm like, oh yeah, and they carry about 100 pounds of kit. And they're like, oh, and it's got to be able to sustain that kit. That kit has to be able to sustain that soldier for 7 to 10 days. And then the tears start happening. And then I'm like, oh, and it needs to be 4x4. It needs to be able to swim. And it needs to be able to survive at least 50 cal, so small arms. And again, he's probably curled up in the fetal position at this point. And that's the problem, right? I can't just say, let's go buy a Tesla. The form factor and the engineering that have to support that vehicle of the future is astronomical, right? And the Army does need to invest S&T and R&T dollars in order to try to figure this out, especially with the drivetrain. Going into the upper left, soldier energy. So if anybody asks me right now, John, is there an electric platform now? And I would like, yes, it's called the Soldier. That man and woman is operating off of batteries right now. And it's effective. All of our equipment in terms of lethality takes a battery. A close combat optic takes a battery, a flashlight, battery. My nods, a battery. So at one point, you'll see a soldier cross LD and he'll have at least 5 to 8 different types of batteries on that person to help him fight that fight. And if you start looking at redundancies for extended operations, he's carrying mass batteries. So you're talking about a lot of weight. But we do have an electrical platform, and that is the Soldier. And we'll come back to him them here in a second. Upper right says base camp. What we're talking about is tactical electric power, right? So everything that will manage and run my mission command nodes or large command post type infrastructure that allow commanders to see the battlefield and manage the battlefield. Again, huge, complex problem. But microgrids, in order to maintain shared energy, reliable energy, is a way forward. Reliable sources of energy. So right now the Army is looking at nuclear, hydrogen, getting off of the diesel fuel, because again, it doesn't make any sense to push energy in order to consume that energy. If I could do that at the point of need, that would be a huge win for the United States Army. And then bottom right, and I kind of mentioned it already, also alternative sources of energy. So back in the 90s, the Army transitioned to a single fuel. We said, let's get away from diesel, MoGas, and all these other types of fuels that, we have to push in order to manage and run our systems. And we went to JP8. For the logistics side of the house, that was a huge win and probably a giant high five. But what that did was it increased the amount of volume I needed because of all of our systems, and then transitioned to that one single source. So having the ability to transition alternative energies or multiple sources of energy and convert them into the power I require would be a huge win as well. So again, huge problem set, right? As the Army's trying to modernize and try to transition off of fossil fuels. And oh, by the way, the planet says thank you too, as we try to look for a transition as well. Again, probably not the #1 priority for the United States Army, but a huge positive as we start to look at transitioning off of fossil fuels as we go towards the required net zero. And then the bottom is the doctrine, right? So I mentioned multi-domain operations, that strategy. I also have the Army modernization strategy, which is then beginning to explain to me how we're going to try to modernize, what are the key objectives that we're trying to achieve. We have the Army climate strategy that was just published that begins to explain to me that not only is my future environment extremely complex, but Mother Nature is going to jump in too and try to disrupt us as well. As we start looking at more littoral areas, arable lands turn into more of a desert or arid climate, and you have huge population migrations. It was only through this working group that I've heard of things called super cities or mega cities, right? So where you have populations of millions looking for work, looking for jobs, or trying to sustain themselves through the government. And that environment is ridiculous for a future commander to actually have to control. And so big arrow is always a good thing because it tells you where we're going to try to go. It's like an avenue of advance or an axis of advance. So in the near term, what's the Army trying to do? I think industry has already solved some of our problems, right? So there's mature technology that we will try to adapt. I was talking with Dean McGrew, anti-idle is one. Additives for fuel is another. There's ways to increase our operational reach and endurance currently right now. And we're targeting the 2.5 ton and below vehicles, right? So that'll be how we kind of test our systems and increase our base knowledge that will inform future decisions. Right now, 2 documents have been approved to include CTT, but the 2 I will mention is ELRV, so the Electric Light Reconnaissance Vehicle, and the Tactical Vehicle Electric. These 2 documents been approved through the AROC process, and it's starting to lay out the Army's modernizations movement and across these time horizons. What that also does is it opens up the doors for analysis of alternatives. It opens the doors towards prototyping. It allows us to actually get soldiers into a vehicle and actually start to test and prove some of the concepts that we're laying out, not only within the strategy, but within those 2 documents. And the resources have to be allocated to that too, right? And we are definitely going to be relying on our industry partners to help us, with the azimuth as we kind of start to fumble our way through what that vehicle looks like. In the midterm, 2.5 to 10, so our medium vehicle fleet, which is pretty much all of our sustainment vehicles. We'll start to look at it. Right now, it's probably going to be a hybrid type vehicle, which is counterintuitive to everything I just kind of mentioned before. Why would I have a combustible engine along with an electric powertrain? That kind of tells me that I've got 2 types of sustainment lines that I've just opened up. And that may or may not be the way the Army wants to go. So it may be range extenders. It may be just technological advances that make the engine more efficient, that give me the requirement that I need. And so another area that will probably drive a lot of the knowledge in this area or in this realm is the autonomous systems, right? So RCV Light is moving out, and a lot of our UAS systems are currently very mature. Battery power, obviously, so increasing their endurance and on-station time is a huge benefit for the Army, and it's going to be a source of exploration for us as we look at different types of sources of energy. And then the far term. This is where things get a little bit more fluffy and ambiguous. And if you were to ask me honestly, the answer is I really don't know. There's a lot of modeling, there's a lot of simulations, there's a lot of testing in the near and mid that will help determine all the decisions that we will make in the far term. And I'm not going to read the slide to you. If you need anything, you can come to us. We have a handout. We'd be more than happy to talk to you about the specifics. But I'm trying to keep it at the wave tops to give you a better understanding of the issues that we're going to face 2040 plus, especially as the threat, right? Because at the end of the day, we're looking for an exquisite answer or solution to this problem, and then the enemy will just destroy it with a $50, off the shelf gimmick that he's transitioned over because he's smart and takes out that capability. So we have to be very, very positive in terms of what we want to do. We have to be very sure about the direction that we want to achieve, or some of the goals and objectives we want to achieve. And so the way that the Army, and at least the way that the Army strategy is trying to support or implement that, is through very innovative implemented solutions to energy storage, so battery capability, in terms of the materials that go into that design, energy generation. I take that back. Energy harvesting, power generation. Thanks, Bruce. Words mean things. So we're looking at advancements in that and those technologies. We're looking at energy distribution, so the ability to distribute energy, not when a soldier gets into a vehicle and he sits down and plugs in, or he sits down on a charge mat, but maybe over distance, right? From platform to soldier, soldier to soldier, and the ability to manage that power or energy. So it's some type of common operating picture that leaders at all levels can manage and actually make good decisions about. These are desired ends. So at the end of the day, when you look at the operational energy strategy sometime this year, what you're going to see is the desired ends. The number one is warfighter capability. At the end of the day, everything that the Army does should always increase that warfighter's capability in terms of survivability and lethality, so he can fight and win on future battlefields. Bottom line. The other one is energy security. So assured energy anywhere, anytime. And the third is energy resilience. So despite disruption from terrain, weather, or the enemy, he's guaranteed that energy in order to power the systems that he needs in order to fight. Conferences like these are extremely important. One, it gives me an ability to talk to you, and we bounce back and forth on what each other is thinking, really. Because at the end of the day, the Army's got to tell you what it needs or wants. And at the end of the day, that takes data. So there's two things that I've been told multiple times: data and material, right? I got to give you the data, and that's what the Army's going to try to figure out. And that strategy will help start that conversation. And then the materials. Once we kind of figure out where we want to go and what we need, you guys come back to us and with the materials. And then ELRV, TAC-VE, and systems like those will begin to broaden the base knowledge that allows Army senior leaders to make better decisions as we start to either transition requirements or those requirements become more mature. And at the end of the day, the enemy also gets a vote. So as our peer and your peers, they begin to modernize, the avenues that they approach will obviously influence the decisions we make. And then our allies and partners across the planet, they're modernizing as well, and the directions that they're moving in, we have to be in line with as well. I'll be here all week, and I've mentioned some names. Please feel free to come up to us, especially if you have a question or you just want a copy of the slides, or you didn't fully understand, again, 10 minutes to kind of tap dance my way through this. So thank you for the opportunity, and I appreciate all that you guys do, not only for the Army, but the United States.
Okay. Hey, folks, we're going to transition to our first panel. And our first one up here, the future of electric vehicles. Again, we're going to dive in on industry and key areas of investment, research, and development. Our panel moderator today is going to be Kyle Teamy. He is with Breakthrough Ventures, Breakthrough Energy. He's also an Army reservist, so he's got kind of two different roles, and he's got a great perspective. He's going to introduce all the panelists that we have coming up here. So without further ado, let's get started. Give him a round of applause, Kyle Teamy and the panelists. Hey, thanks, Kyle.
Thanks, Nick. All right, so let's bring up the rest of the crew. Try to catch up on time here. I'll let them introduce themselves. I'm Kyle Teamy. I'm by day I'm a partner at a venture capital fund that invests mostly in energy and materials. And on the weekend, I'm a colonel in the Army Reserve. I'm the 75th Innovation Command, which helps set this up. My august panel here today, we have some highly accomplished individuals, extremely knowledgeable in all sorts of areas of industry. So without further ado, Tal, go ahead and introduce yourself.
Perfect. I'm Schulkloper. I'm the CEO and co-founder of Voltaic. We're an enterprise battery intelligence company. We help organizations leverage the data from their batteries in order to develop the next generation of products, integrate those batteries directly into end-use products. So we do a whole range of work from across the supply chain, working with new innovative startups, working on things like lithium sulfur batteries, solid state, et cetera, but also work with the large OEMs to make sure they are able to integrate those products efficiently and safely into their products. Excited to be here today.
Hi, everyone. My name is Mujib Ijaz, and I'm the CEO and founder of Our Next Energy. We're a battery company located in Southeast Michigan. Our goal is to double the range of electric vehicles using sustainable materials that we can develop here in North America with a supply chain development that will go along with it. I have worked in battery electric vehicle technologies for 32 years and happy to be with you today. Thanks.
Hi, everyone. Really excited to be here. Today, I'm Chris Thomas. I'm a founder and partner at Assembly Ventures, the first transatlantic mobility fund in the world, so headquartered in Detroit, Berlin, and Silicon Valley. I'm an investment banker in energy and technology, turned U.S. Army officer, communications and signal, turned Yale MBA, and co-founded the first firm in the world uniquely investing in mobility in 2009. So over the course of the last decade, I had the privilege of sourcing, leading, sitting on the board of some of the biggest exits in holistic mobility in the world, one of the largest cash deals in full stack autonomous systems, Uber's first AI acquisition, large telematic acquisitions, about 40 deals, air, land, sea, and space. Assembly is different, and part of the reason I'm so excited here is the two main reasons we exist. One, we believe that we're in the midst of a very real and an increasing in speed bifurcation with the East. So that's any totalitarian regime, but China, Russia especially, in terms of, why is that? Looking at privacy or lack thereof, different institutions. But we believe strongly the future of manufacturing, logistics, and supply chain are going to move offshore of those nations and back to the West. And then two, we believe strongly in the legacy industrial centers of the Western world. So Stuttgart, Munich, Turin, Detroit, Pittsburgh, Tokyo, Seoul, these places have a huge role to play if we make the right partnership, technology, and acquisition decisions. And so as we think about what is the future of mobility, what is the future of energy, I would argue we're talking about the future of the West. And this is an incredibly exciting audience to be talking about just that. So thank you.
Hi, I'm Oh, is it? You guys can hear this okay? Awesome. Yeah, so I'm Doug Campbell. I am the CEO of Solid Power. We are a Colorado-based developer of what's has already been referred to as solid-state batteries. Solid-state battery is you're just simply replacing the liquid or gel electrolyte with a solid electrolyte material. And I like to describe the benefits of solid-state batteries as akin to a three-legged stool. So one, improvements in energy in comparison to today's lithium ion. So think reduced mass and volume for comparable capacity. Number two, increased safety in comparison to lithium ion. And then things like high temperature stability leading to reduction in pack level costs via elimination of pack cooling. We're working with companies like Ford, BMW, and SK Innovation to essentially industrialize and get these into vehicles. So very happy to be with you.
Thanks, gentlemen. All right, so to start off, I spent a lot of my time on active duty in the armored cavalry, so we got to go to the guy rocking a cav mustache here. And we'll start with Chris Thomas. And the specific question for you is, given what you're seeing in the EV markets, tell us what the state of the market is today. What's emerging over the next, let's say, 5-10 years, And what are some technologies that could have applicability to the Army and Department of Defense?
So I always love opportunities to sing to choirs with better voices than me. And so all of you are very deep in different respects, but I'll try to keep it general and kind of go macro down. So the EV marketplace today, as we sit here today, is $300–400 billion in value. Depending on the estimate you look going forward over the next 5 to 8 years, you're looking at 1.3 to 1.5 trillion. So what does that mean? Is it just the vehicle? No. Is it just the component parts going in? No. Is it just the chemistries? No. It's all of these things and a variety of different opportunities that are going to be a part of that ecosystem. So if we go back, way back to 2018, and we look at Europe, they had similar kind of percentage sales penetration to we have in North America right now, about 3 to 4%. As of late last year, they're at 26% of new car sales were EVs. So as we think about where is this going, both globally, but CONUS and around the Western world, it's moving forward at a rate in which it's growing. EVs are growing at 25 times faster than traditional automotive. That means you're going to see a tremendous amount of capital coming into this business. That means you're going to have an incredible amount of new actors coming into this business. And you have some incredibly well-capitalized legacy players who are, some of which are doing it really well, many of which are not. And so the gentlemen you have on this stage, myself excluded, are those that are pushing forward as to how do we do this right for their own individual businesses, but to protect the forward-going opportunities as it relates to EVs. So for me, thank you. So for me, when I think about the opportunity, it certainly is the EV ecosystem. But what is that? What is going to power that? It's looking at differentiated chemistry compositions and rare earths that right now we have some control over, but there's a lot of things we don't. As we think about how are we going to ensure that we have a supply chain that's not sole source, but is robust and has a variety of secondary options for us in the West that will support whatever developmental plan or manufacturing plan we have going forward. That's very important to me, both from an investor lens as well as how do we think about national security. What are the adjacent opportunities? We're starting to see homeowners and builders look at differentiated fast charge being a part of their build out. We're starting to see cities, whether it be through the infrastructure bill with the current administration or ways in which we're trying to make charging much more holistic and easier. We're looking at payment platforms right now that are skewed and, frankly, with the exception of Tesla's supercharger network, not very well ran, and finding holistic ways in which not only can we charge for charging, we can charge for terrestrial movement, parking, gas, charge, C-store, car wash, infrastructure, a variety of different types. These are the things that we get excited about that are adjacent to EV, but are going to be important for EV adoption. And then the last thing I'll throw out there when it comes to, actually, I'm going to read this. There's an article this morning from Paul Linnert, who's a friend with Reuters that you guys may have read either knowingly or in different ways. But it was an article that was titled, "Soaring Battery Costs Fail to Cool Electric Vehicle Sales." So this was top of my reading list this morning. But I thought this quote was super interesting. It's titled "Different Kind of Tipping Point." There's a different kind of tipping point that we seem to have hit, an emotional or psychological tipping point amongst consumers, said the director of the Center for Collaborative Energy Storage Science at Argonne in Chicago. And this is a national laboratory focused uniquely on energy. He said more and more people would buy EVs notwithstanding the cost of battery and the vehicle. What does that mean? It means that we are at the cusp of a huge amount of value creation. And it means that we have a chance from a national defense perspective or posture, or from looking across our allies across the West, to take advantage of that private sector investment to the benefit of what we do in the field and downrange. But we have to start that now. And so I loved what the general said, that tomorrow is worth protecting, but the only way we protect tomorrow is if we start today. We can't wait. This isn't a 6-month plan that's going to kick another 6 months. This is people running hard at these initiatives to figure out how do we integrate technologies in the field, in garrison to begin, CONUS, that maybe go downrange at the right time, but we have to lean in a big way if we're going to do well by the sector, but also by our country and by what I believe are the externalities that'll be super important.
Did you want to add?
Just want to add to that. I think Chris hit the nail on the head here. We've hit that tipping point. We're starting to see the economies of scales of batteries. Anytime you get to this point in an industry where technology grows this quickly, you're going to have supply chain constraints, and we're going to see some, intermittent jumps in, prices of some of these batteries. But similar to, peak oil, peak silicon, all these things, as soon as there is capital, there's going to be the mines that are going to develop domestically to support that industry, and it is going to continue to advance, and the costs are going to continue to drop here. One of the key things with batteries, though, is that the underlying technology is continuing to evolve pretty rapidly here. You have new chemistries, you have new parts of the supply chain, new materials that are being integrated. And so the key is really being able to be agile to look at multiple sources of supply. As he hit on, it's not just single source historically from the older suppliers. You need to really look holistically across the space and be able to integrate those new technologies as they emerge very quickly here.
Thanks, Al. So let's go back to Doug, speaking about chemistries, right? So Doug, I mean, you're at the point of the spear right now, competing actively in the lithium battery space. Talk to us a bit about what the state of the art is, the positives and negatives of those technology, and what you see emerging over the course of the next few years.
Yeah, absolutely. So, I mean, obviously, as we all know, lithium ion essentially composed of a metal oxide cathode, carbon-based anode. That's essentially state of the art. Kudos to industry community. They have done a phenomenal job in sort of eking out, the performance potential that lithium ion can bring to the table. Unfortunately, we're starting to bang our head up against our friend physics. And so that sort of electrode combination is getting to be about as good as it can get. However, and this should resonate, I think, with this audience, everyone is still looking for, more bang for the buck. So more specific energy, more energy density, because as I said before, that leads to a reduction in mass, volume for comparable battery capacity. And that's now where the community has started to look at what's next. And what's next are things like pure metallic lithium, as an anode, which by and large is not considered to be viable, at least in a rechargeable with traditional liquid and gels. Things like high content silicon, we're starting to see little bits of silicon in the anode side. But by introducing large amounts of silicon, that brings about some technical challenges. And so that's where things like solid state come into play. Now, I get a lot of questions like, hey, Doug, why can't I go buy a Ford or a BMW with that solid state battery that I hear great things about? Well, give us some time. I mean, developing new ways to move ions from point A to point B is not a trivial endeavor. Frankly speaking, look at the length of time that it required lithium ion to get invented in the 70s, go through industrialization, and finally appear in cells produced by Sony in camcorders in the 90s. And even then, the performance of those batteries was pretty low in comparison to what we're seeing today. So give us some time. We're working, we're pushing the envelope, and we're pretty excited. And hopefully that addresses your question, Kyle.
Yeah, thanks. And let's go actually over to Majib, who inspired Chris's mustache. And
But he did it so much better.
so Majib,
I don't like how much attention this is getting.
we have a theme. So Majib, you've worked in all sorts of different energy areas. You've also worked on cell chemistries as Doug is currently working. I think an overlooked aspect is there's a tendency to focus in on the chemistry and forget that a battery cell by itself is kind of useless, right? So talk a bit about what you're doing in the next stage. How do you take a cell, turn it into something useful, and what are the opportunities there?
Yeah, thanks for that. When we looked at development of a battery system for the automotive market, we analyzed the content of the cell within the battery system. And if you benchmark the top 5 electric vehicle battery systems that are in the leading brands, you'll get somewhere between 32% and 44% of the battery pack is the actual cell volume itself. And that's a surprisingly low number. And the reason for that is that a battery pack has to accommodate the structure necessary to integrate all the cells together, but also the safety systems that are required to manage the risk of, say, a failure of one cell. In addition to that, the thermal management system that Doug referenced takes up a fair bit of room as well. And as we looked at redeveloping a battery system, we decided to turn the equation around and select a chemistry that would not require as much management from a safety perspective, also a chemistry that would not require as much thermal management. And we were able to move the fraction of cell into the battery pack from 32 and 44% in that range up to 76%. And by doing that, we offer a higher energy density at a system level, eliminating the waste of non-value added materials inside the battery pack. And as we now have started that course of dialogue, we've peeled back the onion on other chemistries that are more abundant in the Earth's crust. And if I think about now nickel and cobalt as being two materials that are often in the news, they're used by battery and OEM developers because of their high energy density. But when you select those chemistries, you're buying into a scarcity burden, which can lead to cost escalation. It can lead to supply chain constraints where the materials are only available in certain countries, turning this now into the next new problem, which is that we end up at a dead end of being able to supply this very large global demand that's coming. So we took a look at the NREL report of 2021, which analysts in the national labs took a hard look at what are the cathode materials that are most abundant and also represent the sustainability march that we're all looking to get on. And we found that iron-based batteries, lithium iron phosphate, and manganese-based batteries, manganese spinel as a type, those are the most significantly abundant cathode materials in the world that can be mined in every geographic location and refined. So we decided to select those as our materials, but not give up on the goal of doubling the range of an electric vehicle by using system architecture and every other tool at our disposal to drive energy density up without requiring the chemistry to do it by itself. And I think that's where the sort of Kyle's questions coming from is that many times we often optimize a component, but fail to recognize that the real value is optimizing the total system. One of the most important things from my objectives in leading Our Next Energy is the safety of the battery should never represent a secondary harm to the occupants of a vehicle. And the first harm is that you might have a crash. And we all understand that that's a reality of life right now. But we don't want a second harm where people are waiting for first responders and the battery fire is what actually does the most damage, or it could actually, in fact, harm or become a fatality just based on the battery fire itself. So we think the chemistry selection and the system design should, at the very foremost objective, prevent thermal runaway and safety hazard that could exist. And I think that's true for all of our men and women in uniform, that if we're going to electrify next generation vehicles on the battlefield, we don't want a secondary harm where something happens and it's not the primary accident, but the secondary event of a battery fire that could actually be the harm that really causes casualties. And so we're working hard on the right materials, the right level of safety, and then better integration at a system level.
Thanks, Majib. And going over to Tal. So Tal, interesting background here, you know, PhD level researcher on batteries, and then decided to bring data science to battery chemistry, which is a pretty unique approach to things. So as you've gone through this, you've learned a lot about battery management, how to monitor what's going on inside the battery, how to get more safety out of existing chemistries, and so on and so forth. Talk to us a bit about what's happening, what's state of the art in battery management, what's the state of the art in quality control and other technologies that can, not just the cell level, but also the pack level, make the whole thing perform better.
So it all comes down to the data and understanding these batteries. There is a tremendous amount of information that we're collecting about these systems in development, in manufacturing, and in operations now with the new telematics systems. Most of that data goes unleveraged today. And so there's a lot of simple things hiding in the data. We're seeing, bad battery packs going into consumers' hands because they're not being identified in the production qualification process. Batteries have telltale signals of starting to have issues in operation, and you could identify those and use them for early service intervention. And so the key is leveraging the data that exists in order to better design, select the right batteries and then operate them in the field. And you're seeing organizations like, Tesla is really the best example here, treating batteries much more like a, software product where they're actively looking at these things. They're able to incorporate change faster. They're able to, you know, modify operation on the fly through over-the-air updates. And that's really going to be the key here is better utilization of the data around these systems in order to really identify signs of early issues in those battery systems. Some of the things that we've seen out there in the space, just in the qualification process, there's often batteries, if you're using top level metrics, everyone cares about, what's the range, how many hours can you get out of that, flashlight or cell phone or laptop. But underneath all that, there's actually, chemistry that you could tell about the batteries just by looking at its, normal charge and discharge. And so we've seen, early signs of chemistry changes, the internal resistances in these batteries evolving, just in the data that's already being collected about them. And then on the in-field side and larger packs, one of the big challenges here is you're sort of limited by that weakest link around your batteries. You're putting hundreds, if not thousands of batteries in series and parallel to build up, the power that you need in your system. And if you don't understand that variability within your pack, you either end up causing safety issues within them, or you're giving up building a pretty large margin around these systems. And so if you look around a lot of the EVs out there in the market, they have pretty significant overbuild as far as the amount of energy in those packs. They're typically derating still from larger OEMs 15 to 20% of the energy in there, and then slowly releasing that to customers over time. But if you better understand those systems, you could start to optimize them, enable things like faster charging, more range out of the products. May not want to do that every day to balance out the life here, but there's a lot of opportunities both to enhance performance and to increase safety just by more actively looking at the data from these products.
Thanks. We're going to go to some questions now from the audience, and I apologize in advance because I will butcher some of your names. But this one is from Shailesh Shah at C5ISR. What are the Eevee battery costs today in terms of dollar per kilowatt hour, and how is that cost being impacted with increasing demand? Want to take that one?
Sure. I think the reports from Benchmark Minerals, which consolidates the cost structure of materials and battery systems quite well, shows that this is the first time in the recent history of battery in which the costs are actually rising. As you look at three very important components of a battery system, the copper, aluminum, and lithium-based pricing, lithium by itself has gone at a level of around 500% where it was before, and let's say a year ago, and then aluminum has actually risen around 50% from this time a year ago. So take just those two materials alone, there's a fairly significant price index that's being applied to lithium-ion batteries, which is around 30%. If you look at the nickel cobalt variations of lithium-ion batteries, sometimes you'll even find that number can be as high as 50%. Prior to that, the targets of the industry were between $130 per kilowatt hour at a system level, and then OEMs had an aspirational target that they would provide battery vendors of around $100 per kilowatt hour. I think it's fair to say that those targets are still in place. They're still part of business plans that justify electric vehicles going forward, but there is a temporary surcharge or a raw materials index that are going to be applied somewhere between 30% and could be higher than that in the near term. The most clear explanation that I can give you for the lithium pricing is the same motivations that cause toilet paper to disappear from the shelves at the beginnings of a pandemic, that's exactly what's going on with lithium and lithium supply and demand, is buyers that can't afford to have an uncertainty are buying the future market of lithium at such a fast rate and at whatever cost is necessary to protect their supply chain, that it's not really that the demand increased that quickly, it's the purchasing of the futures market, and that's where I think some of this pricing index has come from.
Just one quick aside that I think is really important as we think about what does that mean for us? That means that there's a huge opportunity when it comes to raw goods being reutilized from a 360 recycle perspective in ways in which ensure that we have those assets available to us in the West. And that's everything from aluminum to looking at differentiated technology or chemistries within the batteries themselves. This is an immense opportunity. It's not a nice to have. It's something we have to do from a DoD perspective, and also is incredibly profitable and will create value on a forward-going basis. And so I think we're talking about iterative change sometimes. I really like what Majid was talking about in terms of what is the systematic change we need to make. At Assembly, we don't use CASE or ACEs. If you guys are familiar with connected, autonomous, shared electric, this has been the framework through which people have looked at innovation and mobility. I think it's complete rubbish, because it's a combination of technology platforms and business plans. It's just a nice acronym. We put something forward we called ISA, Infrastructure Systems Applications. Infrastructure as the future and the bedrock of the future mobility, systems that connects the physical and the digital, the bytes and the atoms, and applications that allows for customer touch points or monetization. But within the construct of EV, as we think about what is the future forward-going infrastructure we're going to require for EV fleets to be relevant, and not the fleet itself, not necessarily the charge point, but differentiated systems that are going to take more voltage off transformer and allow for fast charge. How are we looking at the way in which these things are going to take place in the field from a systems perspective? This is the right optic, in my opinion, and the right framework to ensure that we're protecting ourselves for a decade from today. And so I challenge all of you to think through this as this is not like just one turn of the wrench. We're using a whole new set of tools, and that's a big opportunity for us.
Oh, sure. Yeah, go ahead.
Actually, if I may get on my soapbox for just a brief moment, and I appreciate the question around battery cost, because as I tell my team over and over again, we're in the business of delivering on low dollar per kilowatt hour, full stop. Solid state for us is a means to get there, but at the end of the day, it's all about dollars per kilowatt hour. And so, the soapbox statement is, and I think we've kind of danced around it, but from my standpoint, and putting lithium costs aside, because I'm fairly optimistic there that over time, lithium assets will be unlocked. As an industry, as a community, we have to get away from nickel and cobalt containing cathode active materials. That is bill of materials, #1 cost driver in battery systems. And if you look at the bill of materials, far and away the bad actor is that nickel and cobalt containing cathode active material. Why is it used? Because it delivers on high capacity. I applaud the use of LFP. LFP is a phenomenal chemistry, and I think it's got great applications. Unfortunately, I don't think LFP is a one-size-fits-all chemistry. We've got to come up with new high-energy cathode capacity. So I'd say if there's any budding entrepreneurs out there that are thinking about, new businesses in the energy storage space, I would zero in on that cathode chemistry. I'd also say there's also a national security issue at play here, which and hopefully this resonates with the DoD community here, which is, we're kind of seeing it right now with what's happening in Ukraine, where you've got Europe kind of stuck between a rock and a hard place because they need to source energy from Russia. My concern is energy storage is going to replace that, and you're talking supply chain up and down where you're sourcing these materials all the way from where you're producing these materials. And right now, the United States does not have a huge role in sourcing of critical materials, and even battery production pales in comparison to what you see what's happening here in Asia. So that's kind of my plea to this community, because absent of the U.S. public sector stepping in, companies like Solid Power will be successful, but I just can't guarantee that what we do will stay here in the United States. And as a patriot, I want to see that happen.
And on my own soapbox, if you happen to be, for example, involved with SBIRs, here's some topics for R&D dollars to go to. If you happen to be involved in acquisition, here are some ideas for what you can be looking at from an acquisition perspective. Okay, another question from the audience. This one's from Lee Robinson at DIU, and I unfortunately can't read the entire thing, but I will hopefully interpret this correctly, which is, DoD vehicles look a lot more like heavy-duty construction, transportation, utility vehicles. So, more like the Tesla Semi than the Model 3, and a fully loaded Tesla Semi at that. So what are we seeing with these heavy-duty vehicles in terms of performance, and what can DoD learn from these emerging heavy-duty vehicles? Anyone? Go on, Chris. You get.
I think it's a challenged use case in the here and now. And so I think we have to be very honest about, and I'd be excited actually if my panel mates disagreed with me on this, but I think I want to see the most agile and completely indestructible assets in the field when it comes to how we think about what we're deploying with our warfighter. I worry about supply chain. I worry about load capacity. I worry about secondary and third order issues with dirty bombs as these things blow up, which they will in the field. And so I think that there's a real, it's very interesting, I think, especially when we think about domestic long haul, but I also happen to think that hydrogen's a much better propellant for that use case. But I think we should be coming back to use cases. This isn't a one-size-fit-all by way of either chemistry, componentry, or asset. I think there's lots of different ways we can be innovative, with everyone in this room to figure out what's the right fleet. I will say a lot of people think about this through the context of like low weight vehicles and or trucks, and I actually think that fleet is where we're going to see a lot of opportunity here, and that applies to this question, but in some ways it doesn't.
From a weight perspective, if you look at the battery system's contribution to the total vehicle weight, it's about 1/3. And if you look at heavy-duty commercial vehicles, it doesn't make sense to start a process where the battery is simply just being held in the vehicle. We need to rethink the battery as a contributing source of structure that a vehicle can be built around. And I think you have so much mass tied up into that component, mass and cost, it makes sense to try to engineer the energy storage function right into the chassis directly and not have them separate like they are right now. So I see a trend where we were, modules inside battery packs, then packs inside vehicles. Then we started dissolving the boundary and made it cell to pack, got rid of modules. That's where we are kind of right now. But I think cell to chassis is a future trend, and cell to chassis has an opportunity to save out of that 1/3 contribution. There's around 10% of the 35% that battery is occupying that could be leveraged by the vehicle itself. And so I think if you're looking for an opportunity to develop a project, I think working with the battery community on chassis to cell combination could yield a lot of advantage.
So there's a follow-on here from Jeff Engler at Wright, who says, what do you think about battery swapping as a solution for some of these problems?
I guess on paper, I think it makes sense. Unfortunately, I've met one credible entity, and they were in China, that was pursuing a battery swapping approach. I'm not aware of anyone else pursuing those. I think one challenge, and again, I'm talking strictly from the commercial side, it would require standardization across OEMs. That will never happen, ever. So, because again, as these automakers look to displace their powertrains with batteries, I mean, let's face it, their powertrains was their differentiator. And so now they're struggling to say, as we move to an electric future, what is our differentiator? Now you want to lump in another requirement, which is you guys are going to use the same battery pack. Ooh, that's pushing a boulder up a hill.
You mean auto companies don't want to work together?
I know. It's a surprise.
It's amazing. I will say, for those of you that remember maybe a company called Better Place, this was attempted, and it was attempted by someone with an ego the size of the state of Texas, in terms of pushing the OEMs to do something that they weren't necessarily against at first, but they were definitely against it once they met him. And so I think what you have here is you have like goodly industrial Midwesterners who are open to new ways to create value, but there's also a lot of ego in all of these rooms. And so how do we, as a community that's focused on, I think, the right end state, which is not just the lethality of our forces in the field, but ensuring that our way of life is not killed. We have a chance to bring these people along, but we can't do it in the old bureaucratic ways. We have to try to bring people along that has, a profit motivation, but also has a chance to have a huge impact. And right now, that has been elusive for our country, especially over the last 30 years. But this is a chance to, begin anew. And I truly believe that if men and women like us lean in a big way.
Yeah, so just go off Majib's point earlier, the big benefits that you can get as far as really integrating those batteries into your structure. You sort of lose that ability as soon as you integrate, swappability into these products. I think there is an opportunity, though, to use those batteries as, auxiliary, just power banks and things like that that could be plugged into these vehicles to top them up. Similarly to soldier power, if you just have a large battery pack within, your backpack there, you could power a lot of those loads rather than having a lot of smaller batteries within those systems. So a lot of opportunities there to utilize batteries, but have to think about that use case and how exactly you integrate those systems and that backup power.
So another question, this is a particularly pointed one, from Kenneth Durbin, Army S&T, and I'm going to do a little twist on it. So he asks, at what point in the future do the panelists believe that battery technology reaches comparable energy density to JP8, so effectively diesel? And the twist I will give is not just battery versus fuel, but powertrain versus powertrain. It's an easy one.
I actually tried to study this for a marine application recently. I asked the question, if you did it on a powertrain basis, how far away is battery technology from fully meeting all the marine requirements? Because we all know that, power and energy and moving boats and ships around, it's the highest drag that you'll have. And the answer was 11 to 1. And 11 to 1 is a very large gap from where we are right now. If you go backwards 30 years and look at the history of battery evolution, just from the 90s to now, it's been a slope of around 6% year over year, which is not bad. I mean, that's actually a reasonably good trajectory, but it will take a long time to cover 11 to 1 between where we are now and where we need to go. I think the answer is going to come not from only solving this at the energy storage level. I think it's going to be a redevelopment of the entire system architecture where you didn't care about weight or drag coefficient because it was unnecessary to care about it. You start bringing the top line need down by improving the way the system architecture works at a mass and an efficiency level, while also bringing up the battery technologies to try to meet that type of goal in the middle. The second thing that I would say is that fuel doesn't always have the same mission profile as electricity and batteries might, because if you're recharging on a daily basis instead of like in a consumer vehicle, like every 2 weeks you fill up, you can see an immediate difference that gives you some advantage as well. So I think it's between mission profile, structure, and mass optimization, efficiency of design, and then battery technology coming up that you'll finally close the loop on all these applications that we haven't yet solved yet with electric vehicle batteries.
Or to Doug?
So to echo, not a fair question. and again, it's not to say that batteries don't need to close the gap or get closer on the gap, but I think it's unfair to expect batteries to completely close that gap, because again, we need to factor in other aspects. I mean, I'm a firm believer in we as a nation, as a society, we have to transition to a clean energy economy. Both in terms of climate change, both in terms of energy security, and so on and so forth. And so you've got to factor that in. And I'll distill it down to a consumer level, because, oftentimes you're at Thanksgiving and you get Uncle Bob and you get Aunt May, who, by the way, always asks you about pack swapping, by the way. I get that all the time. but they ask about, oh, these electric, I don't know about these electric vehicles. And so I don't tackle them from a tree hugger standpoint. Oh, it's clean and, you know, feel good about that. No, I tackle it from two things: cost, total cost of ownership, which again, I get it. Consumers don't necessarily always factor that in, but fleet folks do. And then the other one is performance. You know, my electric vehicle, I'm sorry, there's not a car on the road that can keep up with me. And so, you know, so obviously that's fun. But you factor in all these other things, and then you layer in, at the end of the day, I believe, maybe you do or do not, we do need to transition to this future clean energy economy. And that's where I say it's a little bit unfair. So I'll get off my soapbox.
All right. Let's see. Another one is, this was touched on a little bit earlier. It's a little off topic for us here, but hydrogen, right? And this is from Kushan at Shell. Do you foresee developments in hydrogen fuel cells and availability of hydrogen as a fuel being a challenge to EV forecasts and you know, challenging electric vehicle adoption for supremacy?
I would offer that it's an addition to, and it's a good redundant system. I think that there's going back to use cases, like that's where my mind always goes with these types of propellant questions. There are definitive use cases that hydrogen make perfect sense for. I think you see global entities like Hyundai, you see men like Jose Munoz, the CEO of the Americas, leaning big into like that as a core aspect, a part of what they want to do on a forward-going basis. But I don't think it attrits EVs. To the contrary, I think what we're going to see is kind of a robust development of differentiated powertrains based on different use cases. And I think what we're going to see is an attrition of ICE, of internal combustion engines. I think they will still be there. And I also, something very importantly, there's going to be a big differentiation by geography, in my opinion. I think we're going to see kind of heavy EV penetration and potentially hydrogen penetration for definitive use cases in in North America and Europe and China. I don't think we'll see that in South America. I don't think we'll see that in Africa. I think we'll see a slower migration of new systems for a variety of different macro and micro reasons. But that's not a bad thing. What matters is that we push to make sure that we have security and dependence on ourselves in the West, in my opinion. And for this audience, I would imagine there's a lot of agreements.
All right. And actually, we're running down to our last 5 minutes. So you can add to it, but basically like a minute from each of you, sort of wrapping up and also touching on, you know, what key technologies do you see that are going to be of value to the Army?
Just to add to Chris's point on the hydrogen question, hydrogen is a different form of electricity. If you really come down to the symbiotic relationship of the future of electric vehicles and how batteries will play a role, hydrogen is simply a different form, and they will likely coexist, and I agree with that point. So, sorry, Doug.
Anything else wrapping up points, or?
Why don't you go first? I got my thoughts.
Sure. Well, here, let's go all the way down.
Oh. Okay. I guess, you know, chemistry developer, next generation chemistry developer, it's an incredibly exciting time. I actually echo that. So early on in my career, my engineering mentor taught me that a good solution to an engineering problem is one that shares the pain. So I love that. You know, let's start with the pack level, start with the chemistry level, and meet in the middle. And so a lot of exciting ideas here, but I'll just sort of end with, man, electrification's coming. Both from a consumer standpoint and I assume from a DoD standpoint, and we've got to learn. You know, first of all, we got to develop efficient systems, supply chain security, from a cost standpoint, from a national security standpoint. I will beat that drum over and over.
Totally agree. So I live and work in downtown Detroit. I have the privilege of traveling around to a variety of places around the world, mostly industrial centers, but also entrepreneurial centers. And the question always comes, how do we bring them together? We've done a bad job at doing that. And so for this group, what I want to leave you with is we have a chance right now to ensure that these amazing men and women across our country are unlocked. Their talent is unlocked, their value is unlocked, their work ethic is unlocked. We are doing a very poor job of doing that right now as a nation. We need to figure out a way, not starting necessarily with the federal bureaucracy, but ways in which we can use the biggest tool in our arsenal, in my opinion, which is our armed forces, to unlock this innovation, support these domestic companies that are going to allow us to be energy independent, in a variety of technology dependencies, which are really important. And we have to do it now. And so this is something that we all talk about. This is something that in every conference it comes up, we have to stop talking about it. We have to figure out ways in which, how do we actually bring federal funding to investors that care desperately about the things we're talking about now, and to entrepreneurs that are doing this as well. That is something that whenever it comes up, it's like, well, we can't do that. Federal tender doesn't allow it. We have to figure out a way to make sure federal tender allows it. We have to bring the power of the American Republic and the American Empire to these issues right now, or it will cease to be for our children and our grandchildren.
I don't think I can follow that. That's so inspiring. I'm just going to hand the mic down. Chris is actually really one of my heroes. We've known each other for some time, and we spent some time in Detroit together as well. I think that the time that we're in is like a 100-year event. We're in a really unique time. We're kind of at the time where we're redefining how energy is going to work in the world. And it's everything from the way we live at home, how our grid works, how our mobility works, and potentially how your job as defending our country will work, is going to be transitioning to an entirely different set of technologies. And it may not be complete or a 100% transition, but for sure it's going to have a significant impact in the future of product design and the development of new mobility platforms. And I think that as a country, we're probably 15 years behind many other countries in the world, if not more. That's not a good place to be. We're in the United States of America, but I can't name one US battery company that has the scale of BYD, CATL, Samsung, LG Chem, Panasonic. I can't even name one that could stand up a factory that the US government would fully get behind because they're a US company. We need to fix that. Like, I tell you, if that's the message that I've like really thought about and really started resonating in my mind, is there has to be an evolution of how the US embraces this next generation of energy storage and the technology evolution. And the military and the DoD could have a very big influence on that. I know for sure the Chinese government invested heavily in companies. I watched friend after friend move back from the US to China and start companies that were fully granted the ability with building, land, money, whatever it took. We don't do that here. And we're getting further behind because we're not focused on it. And so I think that transition, we're at least 15 years behind, if not more, and we need to do something to catch up. And that means investment and a concerted effort. And I think the military could play a role in that if you called the industry to action in a meaningful way and then release resources to help enable that.
Amen. Yeah, I think from my perspective, you just look at where industry has taken battery technologies. First, it was in consumer devices. Now we're looking at transportation. We have the powertrains, we have the batteries, and you just look at, we're not going to electrify everything overnight, and we're probably not going to electrify everything. But if you look at those low-hanging fruit right now, you look at microgrids for bases, you look at soldier power, you look at a lot of the lighter duty vehicles, the economics are there. It makes more sense right now from a total cost of ownership, the resiliency perspective, the logistics benefits, and the technology is here today. There's sort of this fallacy of like, we need to wait for battery to cross that chasm to get to that next, same power levels that you're going to get out of JP8. It makes sense today, and there's no reason to wait. And the benefits are actually pretty tremendous. And there's, times now.
Thanks, guys.
Thank you. Thanks, Pat.
Thanks, man. That was awesome. Okay. Hey, we've been sitting down for a little bit. We've got a pretty short lunch break. Find somebody you don't know, take them right outside here. There's lunch everywhere outside of this building. You could also probably grab something quick here if you'd like. But we're going to sit back down here at 12:30. and Kyle will be back up here for our keynote speech. So I'm gonna let you all get to it. I'll see you back here in an hour. Thanks so much.
Thank you. All right, there's a shot.
Hey folks, if we can start to take our seats, like a couple minutes here, we're gonna go ahead and get started. Okay, so find a seat and then we'll get going. All right, hey folks, let's take our seats. Hey Christine, Christine, Christine. Got him. Okay. Okay. I know that was a really quick lunch, and I appreciate your energy and getting back here as fast as possible. We're going to try to keep the programming going here and stay on time as best that we can. But I'll tell you, if you like the first panel, you're definitely going to enjoy the keynote that's coming up here. We're putting Kyle Teamy to work today. He's coming up again. But he'll be the keynote for today, and we'll have our second panel. And then we're going to go into some breakout sessions, and I'll give a couple more administrative instructions after the second panel. But for sure, I think the opportunities kind of like abound here with the folks in this room. So I really appreciate everyone kind of trying to make it back as fast as they can. It's going to be a rush tomorrow and the next day as well, because we want to make it as valuable as possible for you all from a content standpoint. Okay, so Kyle Teamy, again, you saw him on the panel earlier today. He's got a ton of experiences, I think, that he's going to share. But also, he's kind of like a unicorn, right? He's in breakthrough energy, but also has a 75th Innovation Reserve hat as well. And so, my personal experience with him, he just knows the landscape really well, and he has a lot of connections with the Army, has a lot of connections with the private industry that help him stay informed. And so, entrepreneur of several companies and part of an investment, and previously part of an investment team at Incutel. Super, I wrote this down, super smart and a really good dude. He totally is. He's been a big help to me personally. So with that, I'm going to introduce Kyle. Everyone give him a big round of applause, please. Thanks, Kyle.
They told me it was going to be 1 weekend a month. They lied. Nick's been putting me to work, so thanks, boss. All right, so I kind of had two hats on when I was putting this together. It's going to start off very, very high level and drill down to a few things that are pretty tactical, but the idea is to give a little background to folks from the Army, from the military, give a little background to some of the folks here from industry, try to get people talking the same language as much as possible, because we often miss on that when we get into our lingo. And so without further ado, because this is coming from a military background, you got to start with your bottom line up front. So the first thing you're going to hear a lot about over the course of the 3 days is we're in the midst of an energy transition. I mean, what does that mean? I mean, so whenever you're in any form of transition, there's all sorts of interesting challenges and opportunities. Electricity, I think, is something to be aware of. The transition is really to electricity. Like, don't think about renewables or fission or fusion or anything like that. Think about electricity. There's interesting ways and means that exist within the Army to engage in strategic competition. Try to highlight some of those. The panel did a little bit of that as well. Everybody likes to talk about batteries. Think about charging. It was brought up a little bit earlier with battery swapping and other things, but like charging is a core problem that has to be addressed if you're going to electrify platforms. And then there's all sorts of emerging tech, and not just batteries, but some of the stuff alluded to previously that is relevant to microgrids, it's relevant to individual soldier power, motors, magnets, all sorts of things that are emerging with electrification that will have value to the Army, and try to highlight a few of those as well. So starting off really, really, really high level here. Cheap energy is like the core asset for advanced economies, right? Without cheap energy, you don't have advanced economies. It just doesn't happen. And so you can see on this diagram, as you go up and to the right, you've got more advanced economies. As you're down and to the left, you have more developing economies. The folks who are on the lower left part of this want to get up towards where Italy and Germany and Japan are. And so the expectation is you're going to have increased energy usage over time, more and more demand for energy as a whole, as you have 50 to 70% of the world joining the rest of the developed world. So lots and lots of demand for energy. The transition piece, transitions, there's been multiple energy transitions over time. So I think a few points to make here. One is that prior to the 19th century, energy basically meant food and wood. And it was that way for eons. And then in the 19th century, you really had the emergence of coal, and coal beginning to dominate by the late 19th century. And then in the early 20th century, the emergence of petroleum, so oil and gas, and that becoming dominant. And you can see that like there's an exponential growth in overall energy usage as countries, as economies begin to improve their quality of life by relying on cheap energy. And then the emerging transition is the one way up on the tippy top. It's kind of the very beginning of the growth curve that you see for petroleum and for coal. This is starting really like late 20th, early 21st century, which is it's not really renewables. Again, it's getting towards different ways of making electricity. If you look at it rather than energy, like how you're converting that energy into work, this is what Václav Smil calls prime movers. If you ever have trouble sleeping, get a book by Václav Smil. It's like everything you ever wanted to know about energy, and man, it's tough to get through. But you know, food and wood consumed by people and animals, or just burned, and that's how you're getting energy. You see the steam engine emerge as coal takes over. And we're really in the era of the internal combustion engine, right? Most of the work that's realized from energy is different forms of engine. And the interesting part here is what's at the very upper right of that, the electric generator or electric motor. That's what's starting to come on very, very rapidly. And what does this look like with the transition? So you're starting from really low bases with some of these new and emerging energy sources. But you're on the exponential part of the growth curve. And so you're getting annual doubling and sometimes more of these energy sources, these generators. So on the left side there, you can see wind and solar, wind really starting around 2000 to take off, solar around 2010 to take off, exponential growth. These are the cheapest forms of energy on the planet. Right? This is the cheapest energy you can get. This is no longer about subsidies. It's no longer about politics. If you want cheap power, you get wind, you get solar. And even if you add storage, it's cheap. It's really, really cheap. We're talking pennies a kilowatt hour. And that's why this stuff is taking off. The economics are there. The scale is there. The cost structure is there. The returns for industry are there. This is happening. And it's happening very rapidly. And the same thing that the panel mentioned earlier, I think it was Tal brought this up. You're seeing the same thing happen with electric vehicles. So the lithium-ion batteries have hit a point on the cost curve and scale. Costs came down exponentially. Uptake is increasing exponentially. So again, this is for the global vehicle fleet, but it's been doubling every year, the sales as a percentage of overall vehicle sales. So it's taken off, right? This is the market is speaking. This is it's happening. I mentioned to think about this in terms of electricity. It's been mentioned a little bit about nuclear fission. Nuclear fusion is also something we should pay attention to. And this was fascinating to me because I mean, fusion's been talked about for decades. It's always a decade away. It's kind of a running joke. But it's actually, the performance is increasing faster than Moore's Law over the last 40 years. So you're getting a doubling in performance every 1.8 years. And just a few weeks ago, a group in the United Kingdom announced that they went 3x. They produced 3 times more power than they took in. Their problem was they melted their magnets. So it's something to overcome. So they couldn't maintain their containment, but the energy break-evens, which is that red line up there, that's been hit. It's been exceeded. That's a game changer, right? When you can start, that's essentially, infinite energy almost. And it's coming, and it's probably still 10 years out, but it's coming, and it's something to keep in the back of your mind as we're going through this. And you should also, I mean, I mentioned the melting magnets, but the kinds of magnets that are being developed for this are really interesting for military applications. for catapults on a aircraft carrier, for rail guns, for all sorts of different applications. It's really, really cool stuff that's going to have other applications. All right, so we're heading towards like unlimited, really cheap energy from renewables, from fusion, from fission. There's always a trade-off. Like nothing's free. So the trade-off here is really about minerals. It's about materials. Folks talk a lot about rare earths. It's not just rare earths. Cobalt and nickel were brought up previously. It's also copper. The amount of copper required for these things is just absolutely unbelievable. And with the core materials required for electrification of transportation and for some of these technologies for energy generation, you're going to have to increase production of key minerals anywhere from 2x to 10x over the course of the next decade or so, based on existing demand, which is a lot. I mean, it's a lot. It's going to have all sorts of implications across supply chains, across countries. It's going to change geopolitics. There's going to be a lot of interesting things coming out of this. And another thing the panel mentioned this morning is there's a high concentration of these minerals in certain countries. The U.S. military for decades had to deal with the concentration of oil in the Middle East. That was a recurring theme in conflicts over the course of the last 60 plus years. It's kind of hard to see here, but the concentration of oil and natural gas is on the left-hand chart at the top. It's roughly like 40%-ish in your top 3 countries. As you get into some of the minerals that are required for electrification, that are required for batteries and such, the concentrations are even higher, right? So cobalt, 60%, 70% of the global cobalt supply is in one country. And that's the Democratic Republic of Congo. So there's some pretty tough neighborhoods there. And then, when you get into the right-hand side of this chart, which again, I understand is hard to see, that's on the processing side. So it's not just the sourcing. You have to take the source mineral and then turn it to something useful. Almost all the processing is in China. Like over 50% for most of the key materials is located in China. There's effectively no industrial base in the United States for a lot of these things. Effectively no industrial base in Europe for a lot of these things. There's effectively no industrial base in a lot of our allies for a lot of these things. That's not really a good thing. So very important thing to think about, not just the source of the mineral, but how are you actually processing it into something useful. And as we think about these emerging issues with different minerals and things, oil's not going away either, right? So the amount of oil required is probably going to decline over time. These are projections from BP, so they tend to be a little more bullish, but even the most bullish scenario from the oil industry has oil demand declining over the next 30 years and declining substantially, anywhere from 20 to 80%. And so certainly you will see a decline in oil demand, but oil still remains important. It doesn't go away. So you've got a transition to new energy sources. The old energy sources remain important, which means we have a lot more to worry about from a military perspective. And really the so what is, you're just going to see a lot of volatility, right? So you've got petrostates, like the high cost producers are going to get killed as they no longer can rely on their oil sales. You're going to see instability in places like that. On the mineral rich state sides, you're going to see countries that weren't previously powerhouses suddenly become powerhouses in different ways, and suddenly they have a lot more money, they have a lot more power over supply chains, over the world economy. And then you have a competition for resources that we really haven't seen in a century. Like the last time really was the big competition to get access to oil and gas. Same thing it's been happening already for the last 10 plus years, but it's just going to increase as people start, and companies and countries start competing for access to materials and minerals. This was mentioned a little bit, but And this stuff I've been talking about is all very high level, is geopolitics and macroeconomics and some microeconomics, but like it's very high level. But you know, how do you compete as the Army, which is something we try to think about at the 75th all the time. But there's really interesting tools already, right? Like the SBIR program is a really interesting tool for funding early stage technologies, and you can fund technology into alternative materials, into materials efficiency, into ways of extracting materials. DoD and the Army have for decades led, been ahead of the private sector and really incubated new technologies in the private sector that have become important. It's a critical role. It has been historically. It'll continue to be one. And so there's lots of ways that R&D funds can be leveraged. You've also got the ability to do demand pull on finished products. So if I mentioned the lack of processing capabilities, the lack of industrial capacity. As was mentioned on the prior panel, if DoD says we're going to put microgrids on every post, we're going to compete in Europe by taking all of our garrisons and putting them on microgrids, 100% renewable, and no longer by natural gas. It's just imminently doable and probably cheaper than what you're paying today. It solves multiple problems. It lets you hit the climate goals. It lets you hit resiliency goals. It lets you do a lot of things. But from an industrial policy perspective, it also is demand pull on the production of equipment that matters this century. And then there's also, I mean, getting into the manufacturing side of things, there's Title III, there's all sorts of capabilities that DoD brings to bear. All right, so that's the really super high level stuff. Kind of drilling down to operational. And again, I'm just trying to give one over the world and set some context for the next few days. Putting on my military hat, I had to go back to doctrine. I pulled up a chunk of an Army publication on logistics. And this is a chart of what it looks like at a very high level for delivering fuel into theater. And really what does this mean? Like, it means that if you've got 100,000 troops and you put them somewhere around the world, you're going to be delivering about 2 to 2.5 million gallons of JP8, so diesel-like fuel, per day. And you're going to be pulling that from wherever you can pull it from. As the speaker earlier was saying, sometimes it's bought off the economy, sometimes it's delivered from the U.S. It has to get delivered, though. People die delivering that. People get hurt delivering that. Stuff gets blown up delivering that. It's a critical weakness. It's also super expensive. So the effective cost here is, $45 a gallon. And I mean, the Navy claims it's as high as $400 a gallon. It's all kind of who you ask and what theater and what situation. But the point is, it's a lot more expensive than going down to, the local gas station. So super expensive, super difficult, big challenge. And General Mattis, then General Mattis said, unleash us from the tether of fuel. And this is something that's been brought up repeatedly. Like, how do we deal with this thing that really is, it's arguably the greatest logistical constraint on Army operations. And oftentimes what people want is this. So this is Mr. Fusion from Back to the Future. Mr. Fusion will solve all our problems. Everybody wants, the magical technology. Unfortunately, we have to obey the laws of thermodynamics, as Homer said to Lisa when she made a perpetual motion machine. So you can't just have it that simple. It's always, this stuff is a giant pain in the ass. Let's be honest, right? There's no simple answers here. But there are still some opportunities, right? So there's going to be all sorts of opportunities, some of which we discussed earlier. There was a lot of focus on batteries on the panel this morning, but there's more to it, right? So silicon carbide based power electronics are coming on strong right now because of electric vehicles. There's some really, really cool stuff you can do with silicon carbide when it's cheap, when it's plentiful from industry, that I think will have impacts across many different programs that Army's currently working on. Improved electric motors are another one. I think we'll hear more about that this afternoon when folks get into the aviation side of things, but like electric motors critically important to many different things. And for electric vehicles and for electric aircraft, you need improved efficiency, you need different kinds of magnets, you need all sorts of different things that can be helpful. Same thing with control systems and on and on. I had to throw this up as an example for electrification. This is an extreme example, but this is from the National Academies of Sciences and is a comparison of what it looks like to electrify an M1 versus run it on JP8. I think that the key numbers are in red up there. So it's basically need more than 20 times the weight and volume that would be used for liquid fuel today to move around a tank. That's pretty tough. And then you throw in that you need it to be safe, it can't explode, it has to charge fast. Like there's a bunch of requirements here. It's going to be really tough to get major platforms electrified. And I mean, even when you're talking about a Humvee or some of the lighter weight pieces of equipment, it still is non-trivial. And the part that it unfortunately is not talked about enough is charging. So this is a refuel on the move. This is, you know, every so often a unit has to come together, they have to get refueled, and then they head back out and do their thing. I used to be in the OPFOR at Fort Irwin. We used to, like, this was one of the core things we were looking for with our scouts was when are they refueling, and then we're going to drop all the artillery we have on them and like make their life miserable, because this is when folks are they're most exposed. Like they're easiest to kill when they're all coming together to fuel up. So this is a real problem for fueling, but think about doing this with charging, right? And so we talk about, okay, we're going to charge overnight. That's great at a house, right? But if you have to take 8 hours to charge your tactical vehicle, it's just not happening. And so realistically, you need to charge fast, right? You need to charge on the same amount of time that it's going to take to refuel with liquid fuel. So it's an example of also from the National Academies, 15-minute charging for one vehicle is an M1 again. So 33 megawatts of power required. So if I want to do a battalion, I'm talking 1.5 gigawatts of power to charge a battalion. You know, brigade level, you're talking 5, 6, 7 gigawatts, right? So if you just think about this, the logistics of this, it's daunting at best. It's the recharging part is really, really hard. It also means you probably have to go nuclear because if you're just sending fuel to crappy generators that are 20% efficient and using those to charge your electric vehicle fleet, you're still using ridiculous amounts of liquid fuels. You can't use solar because you'd have to cover square miles of land and like drag that behind you as you're marching on Baghdad. Same problem with wind, any sort of renewables. So you really, I mean, what's your option left is pretty much nuclear. And then what happens when one of those is hit, because you basically are driving around with a dirty bomb next to you at all times, and that sucks. So you have to have some way of making that so it's not going to kill everybody. Going even more tactical and related to charging mobile microgrids. So this is something the military does everywhere. You have to set up your operation centers and other things. So constantly setting up little mobile microgrids. Some ideas there for folks from an industry background, but you need something very robust, very safe, super quick, super easy. 18-year-old that barely finished high school can set up. Has to be flexible so you can use all sorts of different power sources. So, you know, there's some engineering challenges there, but I actually think there's tons of opportunities here, right? There's tons of stuff coming out of private industry that is relevant. The efficiency of Army equipment, and again, I don't mean to be disparaging, but it sucks, right? Like let's be straight. Like the generators used by the Army are very crappy. And there's room to improve there. There's room for hybridization. There's room for better controls. There's a lot of room to borrow from private sector. And then getting to soldier power, the battery piece was mentioned before. I again remember being a young guy and walking up on a hill with like half my pack being batteries. and like 15 different kinds of batteries because every single piece of equipment I had a different kind of battery, and that sucked. And you like realize that your 9-volt died because it got too cold out, and all sorts of crappy things would happen. I think this is another area where the private sector can help, right? If you look at the consumer devices that all of us have with us, I mean, how many of you have ever changed the battery on your smartwatch? Like 0, because they're designed for recharging. Hey, so maybe rather than think of that this as a battery problem, we can think of it as a charging problem, and get to easier form factors that way. Again, borrowing ideas from the private sector, look at portable power generation rather than like battery swapping. It might be a way to do it, just as a random idea. So back to my summary. I already said this stuff already. I don't need to repeat it. I think I have like a minute and a half left for maybe.
Kyle, thanks so much. Really appreciate it. We've got time for maybe two questions here. So if you got good ones, feel free to use the bit.ly link or the QR code. First question is, can you discuss the environmental concerns with batteries and the business case for end-of-life recycling with batteries?
Yeah. So, I mean, mining is environmentally destructive. And the materials used in a lot of different batteries are toxic. And so it's this is actually why a lot of manufacturing ended up in China, because of environmental laws in a lot of countries. It was more expensive to manufacture in many areas. China just said, we don't care. Like, let's go do this. And so it's all stuff you can manage. It's all stuff that's handleable, but it's an expense effectively. And then on the end of life, the recycling, there's a bunch of companies that have merged in the last few years to handle the recycling. I'm pretty bullish on the capabilities to do that. There's a bunch of different techniques emerging, but it's not going to be easy, but it'll work. It'll happen. And that's actually going to help with some of the supply constraints as well.
Thank you. The next question is, what is the opportunity for like recharge stations that are making an impact on the commercial sector, but what is the opportunity for those types of recharge stations in the DoD world? Is it going to be totally different needs and requirements, or is there a lot of overlap there?
I think we have to separate the concepts between what you do in garrison with like a mill van fleet versus what you're going to do operationally. The garrison operations, if you're going to have your different I don't know, like pickup trucks and stuff that folks have to drive around at like Fort Hood, you certainly can use civilian charging infrastructure for those sorts of situations. And it actually makes perfect sense. I mean, going back to some of the stuff Chris was talking about this morning, it's stupid we don't already do this stuff, because you get big advantages on fleet operation. It's super low cost to maintain the fleet. Like maintenance basically goes away. There's some good advantages, and the charging systems exist. The amount of miles that you drive around one post are small, right? So it's pretty ideal for those sorts of things. On the operational side, you have fast chargers available, and that's great. But I still don't know what the underlying energy source is going to be to put the energy through the charger to the tactical vehicle. That's the big question in my mind is what energy source could you actually use in an operational standpoint or operational situation?
Thank you. And I think this will be our last one here, but a theme that's sort of popped up over your session and the previous panel is this, there's not going to be a one size fits all. There's kind of going to be a spectrum of technologies that are needed. So our last question is, do you see a role for electromechanical storage, such as flywheel technologies, in a operational environment?
I don't know. So, I mean, I'm definitely not an expert on that area, but I mean, the use case where flywheels have been good has been for very fast response. I mean, they're effectively like a capacitor, and so they've worked really well for like frequency response and things on the grid. You're going to hear this afternoon with the aviation folks, but but we've talked pretty much only about energy density. We haven't talked about power density. And so for a lot of applications, power density matters. And that's where I think you might have some sort of hybrid type situation where capacitor-like things put together with batteries could emerge for sure. Yeah, sure. All right, thanks.
Kyle, thank you so much. Really appreciate it.
Thanks, Scott. Awesome. Thank you. Awesome. Well, okay, I'm going to try not to rush through this thing so we're all set up for the next panel here. I think we are. I think we're good. So we'll kind of jump right into it. If you guys got to go take a bathroom break, do your thing. But we're going to jump right into the electric aviation reality check. We're going to discuss challenges to air platform electrification, including design, weight, and range, and a whole lot of other topics. I'm going to introduce the moderator, Mike Wu. He's a principal at Converge Strategies and has quite a bit of experience in policy and an advisor to energy resilience and clean energy for the Air Force in a previous life. He's also previously founded the Defense Energy Program at the Truman National Security Project, and which is advocating policy towards clean energy initiatives in the military. He's also a lawyer, so again, really smart person. Mike, if you can come on up, thanks for joining and moderating the panel, and then everyone else as well, please. Thanks. Awesome. You want to get a microphone? Microphone, perfect.
Hey, everybody. Good afternoon. Thanks, Nick, for that introduction, and thanks everybody at the Army Futures Command and Army Applications Lab for putting together an incredible event. As he mentioned, my name is Mike Wu. I'm the principal and co-founder of Converge Strategies. We're a consulting firm focused on the intersection of clean energy, resilience, and national security. I'm also the executive director of the Resilient Infrastructure and Secure Energy Consortium, which is a private sector coalition of more than 400 technology providers, utilities, national laboratories, universities, nonprofit research organizations, and others dedicated to clean energy and climate action for DoD and the rest of the federal government. You can learn more about that at rise-consortium.org. It's free to join. I'd love to answer questions about the RISE Consortium after this panel, because I'm really excited for the conversation we're going to have on flight electrification and the future of air mobility and air transportation. We have a really tremendous set of entrepreneurs and technical experts who are at the cutting edge of these advanced technologies and are going to take us into the air in the future. So I want to start, well, first of all, as you guys have heard in previous sessions, we will be doing audience Q&A, and you can access through the QR code right in front of you on the chairs. But I want to start this conversation really, and maybe I'll start with Jeff Engler, who's the CEO of Wright Electric. Do you have yeah, okay. And Jeff, really what I'd like to do is just give this audience an understanding of air mobility and air transportation markets, and understanding really what we're trying to do is understand what technologies are appropriate for what use cases within this field, and understanding the relative market sizes, challenges, and opportunities associated with that.
Absolutely. Everyone can hear me okay? All right, perfect. Great. Jeff Engler, founder and CEO of Wright. Thanks a lot for having me today. So one of the things that we're going to get to talk about today is different classes of aviation. So you'll hear from companies working on small electric vertical takeoff and landing aircraft, sort of like small helicopters. You'll hear people talking about regional jets, and then also to larger commercial aircraft. One of the things that we found interesting when we started our company about 5 years ago was that about 95% of the value of the commercial aerospace industry, whether you look at the value of the airplanes or for example, the revenue passenger miles, is airplanes larger than about 100 seats. So that's the typical Boeing and Airbus market. Airplanes like the 737, Airbus A320, and then going up to transatlantic as well. An equivalent of, let's say, a 737 is, let's say, a C-130 in terms of let's say the size of the aircraft. And so what we decided when we started the company was that if we wanted to make a difference in the industry, and if we wanted to help accelerate the transition to electrification, we needed to get to that very large airplane size. because if we started with things like Cessnas and smaller airplanes, we just weren't going to make that much of a difference. And what that let us do is to start building components for large airplanes of that size, over 100 passengers. We started by building a 2 megawatt electric motor, so that's about 10 times the size of let's say an electric motor on a Tesla, designed specifically for very large airplanes. But what was interesting about that, and this is something actually that Kyle just mentioned earlier, was that as we started developing what's essentially a very powerful, very lightweight electric motor, we found that there were other applications, including Department of Defense applications. So we recently received a contract from the Air Force to turn this megawatt class electric motor into a generator specifically to be used for charging of electric vehicles. So, Kyle mentioned that we'll need to move to nuclear. As a transitional step, a typical generator that you might see already in use on the ground, but scaled up to the megawatt class, could be a great way to start enabling the transition to the electrification of vehicles. So happy to talk more about that. But again, thanks for having me.
Yeah, I think that's a really important note that you draw out, Jeff, around the way in which a lot of the propulsion systems and drivetrains and things like that for aeronautical use are also, in this case, really interesting for other applications. And I think that's a good transition to Gabe DeVault from ZeroAvia, who's the head of drivetrain development at ZeroAvia. Gabe, you and I talked about previously about some of the infrastructure challenges, and Kyle noted for us previously a lot about the opportunities associated with platform electrification that we're seeing, and we heard a lot about that from the Eevee group. But I think also we're going to encounter a lot of challenges around infrastructure. We're seeing that on the Eevee vehicle side, right? The electric vehicle side and ground transportation. Tell me a little bit about the infrastructure challenges around aeronautical applications, and what is ZeroAvia doing to address some of those challenges?
Hello, everyone. I'm Gabe DeVault with ZeroAvia, head of test and application. In regards to infrastructure, our focus is really on, I guess you could compare it to the Tesla supercharger model, so that you can't just roll out a motor or a battery for aerospace without back-end infrastructure to support it. I don't think anybody here would think Tesla would be successful had they not rolled out the supercharger network to support the cars. So we are working hand in hand with a number of industry leaders. For example, Shell is one of our investors. They are the largest, if not one of the largest fuel suppliers for aviation industry worldwide. And we are working with Shell and the new company called ZevStation to basically do kind of a smart grid system for hydrogen distribution in California initially. We have a pilot program in our Kemble facility where we actually make our own hydrogen from electrolyzers, and we actually fly hydrogen fuel cell aircraft on the hydrogen that we make. So the technology is there. It's really just a scaling, to match the demand. So that's, I think, the biggest challenge is actually not really the technology. Electrolyzers are there, PV, renewables are there. It's really rolling out the infrastructure in lockstep with the industry and the demand to satisfy demand as needed.
Gabe, let me drill down a little bit deeper on that, because there seem to me to be two models in this that are at least where the technology is. One model being sort of grid charging infrastructure for electric flight. One model being more focused on creating fuels that then are used, like hydrogen, that then are used in order to power electric drivetrains. So can you talk a little bit about the distinction between those, the differing requirements between those, and a little bit about what model you're pursuing?
Yeah, so our model is really based on sort of local manufacturing, supply, and storage. So electrolyzers, preferably green electrolyzers, grid connected, and you're making your hydrogen on site and more or less on demand, buffered to whatever you need to do for the local area. But this means that you don't have hydrogen trucks or pipelines or And you can also, by deploying a lot of renewable on the local grid, what's really nice is you have a symbiotic relationship between electrolyzing hydrogen and renewables, so that, as you guys all know, I'm sure, renewables have a very fluctuating power demand for power generation. When you have electrolyzers, you can actually turn the production up when the power generation is up, and you can turn it down when it's down. And so you can put a lot of renewables onto a grid that normally would be very hard to have a stable grid. And using the electrolyzers, you can basically knock the peaks off of all the production and maintain a nice stable grid and take advantage of the low power or low energy costs when it's cheap.
And contrasting that with grid charging for electric flight.
Yeah, so as an example, standard automotive hydrogen fueling, it's called a WEH16 nozzle, can do something like over 100 kilograms an hour of hydrogen transfer. This comes out to several megawatt hours in equivalent electric power. A charge connector for a multi-megawatt charge connector is going to be giant. I mean, even the high power ones today are large, water-cooled, complex things. A hydrogen fuel connector is actually very simple. Just stick it on, click the nozzle, and it just goes. So I think that's another area it was touched on earlier about how do you charge an M1 Abrams or something. And you could fill it with hydrogen a lot easier than you could by charging it with some multi-megawatt charging system.
Awesome. Yeah, we said it was going to be a reality check, so that's what we're going to do. I think that's also a really interesting path, because one of the things that we're talking about are the opportunities to transform existing models of air mobility and air transportation. And I know that there's some of us on stage who are also focused on transforming other models of current mobility into air mobility. And that's why I want to turn to Ian Randall, who's the CEO and founder of Maglev Aero. So Ian, tell us a little bit. I know your company is a very low profile, but tell us a little bit about your visioning for the future around air mobility, particularly for things like urban applications.
Super excited to be here. You guys are asking all the right questions, and I'm excited to be part of that. It's really interesting to talk about the power and how you actually supply the electrons. But looking at the mission is actually really important. When you look at how people travel within city centers and between city centers, you notice a lot of the density of these traffic is within 60 miles or within 200 miles that you guys are looking at. And that's where the question for what is the comparison between fuel, jet fuel versus electric propulsion to whole drivetrain really comes into place, because you're looking at how well the system is actually achieving the mission. So for urban air mobility and advanced air mobility and regional air mobility, the solution is providing the fastest, least frictional transportation from where you want to start your trip to where you want to end your trip at the lowest cost and least environmentally impactful way. So that's not only with the energy usage and production, but also how much of a nuisance it is to the people in the areas that you're flying. And I know noise and efficiency is really important for the urban applications, but I can imagine it's also fairly important for military as well.
Absolutely, and that actually is exactly where I wanted to turn. We're lucky to have Dr. Maruti Akila, who's a director of aerospace engineering at UT Austin. Maruti, we talked a little bit previously about your work around thinking about contested and remote environments and military applications. And I'm curious about how, some of the conversation that we're hearing is striking you, particularly around how do we get these kinds of platforms into a battle space, and what are the implications of that?
Well, thank you.
We may be having a problem with the mic.
Okay, hope you can all hear me. Thanks.
I think you need to hold it closer. Yeah, there you go.
It's a pleasure to be here, and so I'm from the University of Texas at Austin in the Aerospace Engineering Department. So unlike all my distinguished panel colleagues, I wear the academic hat, and so That's a great question, and I'm not, by training in the energy sector. My expertise and all my work is in robotics, autonomy, and controls for air vehicles and also for space vehicles. And obviously, we are talking here about the next generation power systems, which is the electric reality, and that's got huge implications both on the commercial civilian sector, but also in the military and DoD context. And I can touch upon both areas, but most intimately with respect to the military applications, the use cases are phenomenal. And I think the previous talk also touched upon all the challenges out there in terms of ruggedization, interoperability, securing the power infrastructure and installations. But the most important aspect from an air mobility standpoint or an air vehicle standpoint is really getting the powertrain into the size and form factor that we can actually fly the system. Air vehicles are different from your self-driving cars or your other electric vehicles on the ground. And some of them could be vertical lift, some of them could be vertical lift but transition to forward flight, where they generate lift using lifting surfaces so that they can actually get some range. And it also depends upon whether you're talking about a 60 to 200 mile radius, or whether you're talking maybe more like, going from state A to state B, or, regional transportation. And that is important even for the military, depending on the size of the theater that you're contesting on. And so I think we come back to what I say. It sounds as a cliche, but I don't see as one size fits all. There's got to be unique solutions for each use case that you need to develop and also optimize. But the other reality is that we're going to deal with a very long transition. There is going to be a coexistence between the way we have been doing things, and we will continue to do that for the next at least couple of decades or so, as we keep our eye on what do we need, what infrastructure do we need to build, how do we bring the right policy prescriptions to encourage and stimulate those developments so that we achieve the reality of electric air mobility.
Yeah, totally. And I think that really prompts a question for the three entrepreneurs on the panel. You guys are all making big bets, right? You're making bets with your time and your companies about what that future use case looks like, and that there's a market there. What are some of the things that you'll be sort of considering as gateways or waypoints to feel like you're on the right track? What are the kinds of things that you want to see in the environment that would make you confident, or investments that would make you confident that you're on the right track for what you're trying to accomplish?
I'll take that. Yeah, so our company was founded by Val Mifkatov, who previously started basically a smart grid company, chargers. You can buy them in Costco, et cetera. And he did really sort of a first principles analysis of EV market space and where could he make a big contribution. And when you look at just the, again, like raw first principles physics, the bottom line is battery is only going to get you a few hundred miles, maybe, with current technology. So good for urban air mobility, urban air taxi. Maybe eventually it'll get to sort of short range regional, but the end of it just basically comes out that it's hydrogen. Hydrogen is the only solution that gets you to a true carbon-free, net solution that'll get to, many hundreds or thousands of miles. And where we are now is with our standard conversions that we're doing right now, we're looking at 300 to 500 miles. This is just taking an existing aircraft, converting to gaseous hydrogen using current off-the-shelf low-temperature PEM fuel cells. And it's compelling for some product, not everything, but there's real product to be made in that scale. The next scale will be basically, just as he was saying, better integration with the airframe and the propulsion system. So as the airframes get built bespoke to a specific power plant, have fuel storage sculpted to the right shape and size for the hydrogen, I think we'll get to about 1,000 miles range on gaseous hydrogen. To get much beyond that, you have to go to cryo. And cryofuels, cryohydrogen will get us to parity with JP8. So those are the real milestones, I think, is one, airframe sort of maturation and integration, and then the eventual transition to cryo is where we'll really become full parity with existing fossil fuel aircraft.
Jeff? Yeah.
Yeah, happy to add a little more context as well to that. When folks think about how important it is to transition flying from existing fuels to electric or to zero emissions, it's important to look at, and I'm not sure if people realize how bad flying is for the environment. You would have to, just to give you a sense, for many, so I came in from New York. Some of you probably came in from California, so that's a flight of a couple hours. If you were to if you were to do a single round trip 2-hour flight, you would have to eat vegetarian for over a year to offset the carbon emissions of just your seat on just that one round trip flight. And I imagine the people in this room are flying all the time. So for many of the people in the room, probably flying is the single biggest thing that they do for the environment, often by a factor of 2 or 3. And so if we want to start to reduce the climate impact of transportation, we have to be focusing on this space. I mean, as you mentioned earlier, we have to be focusing on airplanes that are going relatively long distances and sort of larger sizes, because that's where the emissions are. So as we see that transition, improving the energy density of hydrogen fuel cells, our company is also working on aluminum fuel cells, which have some advantages over hydrogen and still let you go long distances. And also the propulsion systems. Making megawatt class propulsion systems to allow you to generate the same amount of thrust that's on a jet engine is crucial. And then integrating those propulsion systems into the aircraft in an aerodynamically efficient way. These are all the things that are going to lead to the transition. It's not about demand. Everybody knows that there's demand. You're going to get airplanes that are lower carbon, and also, much more importantly, at least for this audience, much quieter as well. So from a commercial perspective, of course you want it to be quieter. From a military perspective, there's numerous advantages as well. So there's unlimited demand for these technologies. The question is how do you actually build the technology to enable it? And it's a combination of propulsion, energy storage, and then integration into the aircraft.
Awesome. Yeah, and then what about urban applications?
For urban applications, the look at range and extending range, it's an important target, it's an important objective. But right now, where, for urban applications, the range objectives aren't that severe. And weirdly enough, it's not the energy capacity that sizes these vehicles as much as you'd think. It's really the specific, or at least the power density of the batteries that size the vehicles in the fault cases, when your props down or when you have battery systems down and you need to accelerate out of a maneuver, where safety and resiliency is paramount. So I think battery systems is a really important factor, but not in the way that I think a lot of people. Of course, energy density is always fantastic. It's always great to be able to do more and therefore have more, reserve. But power density is really key with these vehicles that are, taking off from hovering flight, which is really a very significant thing to hold something in the air stationarily. So I'd say seeing advancements in not only the energy density, but the power density at that energy density is going to be really significant for the industry, as well as, for these vehicles, you want people to be able to access the technology, access the service, and so you want the cost to be low as you're around the area of a taxi ride. And to be able to do that, you need to be providing a lot of flights per day, in per day, per week, per month, per year, with very little downtime. And, you know, some of the Army folks understand some of the, the work involved in maintaining a helicopter, with many hours required in service and overhaul per single hour of flight time. So improving the frequency at which you can fly, and therefore the speed at which you can deliver power to these vehicles so they can get back into the air is some key drivers. So looking into those areas is very significant. And I imagine, you know, I don't know if military has the same range objectives as urban air mobility, but throughput is a common theme between them. How fast can you, or how much payload per hour, per day, can you, you know, transport over a certain range? And the ability to, you know, have that power on board and deliver the power to the vehicle is important.
And Marissa, you actually touched on this up front about policy prescriptions and about, you know, ways we will be expressing our vision for the future of this country, the future of our military, through expressions of policy. And I'm wondering what those policy prescriptions might look like. We heard about the Army climate strategy this morning, and in addition, there's certainly a lot of investment around this space. But what are some of the policies that you would envision driving this future, and what are their relative permutations that we might see that would sort of create alternate paths or alternate incentives?
Yeah, well, I mean, from my perspective, I think some great points brought up, especially when you're talking about air vehicles. The density is energy density and power density are both crucial factors, and that is agnostic to the range. And it's not just what it takes to power the airframe or the vehicle, but also the supporting infrastructure around it. For example, I mean, to make an airplane reliably go from point A to point B, and whether it's carrying people or whether it's carrying cargo or ISR or some other sensitive payloads that the DoD cares to carry about, you need to have reliable supporting infrastructure that comes from assured positioning, timing, navigation, to deal with micro weather or unanticipated events that are happening. And of course, that is in the urban context. But now if you take it a step forward and you're talking operating inside contested or denied environments, then there is clearly scope for adversarial action. And so where does policy come in? I think there's talk about, let's say you're talking battery technologies customized for air vehicles, whether they are ISR platforms or whether they are one or two soldier mobility carriers. So there's going to be a lot of careful planning that needs to go for how do we source the materials and how do we ensure that they are available for us on a consistent basis, that we can count upon, our industry can count upon to deliver the equipment and the supply chain that takes to field and deploy these technologies. And the same thing goes for even shaping how you come up with solutions that are enabling these new generation airframes. For example, if you are talking about one vehicle to go and deliver a payload at a certain place, is there efficiencies built in terms of scheduling the route in such a way that you can do multiple deliveries on the same route? And so there is going to be also a lot of incentives that come in terms of how you optimize your trajectories. And that has got to do with appropriate policy incentives so that the marketplace can respond and take benefit. It's just like, earlier in the time, and maybe it's still true, that, you go buy an electric vehicle, you get a federal rebate. And that is, trying to kickstart the demand. And of course, then the market will respond. And I think to some extent that has to happen, and I think the DoD can drive that transformation.
Absolutely, yeah. There has to be some kind of investment from government action that will help alleviate risk and help accelerate adoption. But I think there's another path to that, or another component of that, particularly as it comes to air mobility. And you touched on this for a second about safety. And I'm wondering about, your respective sort of engagements and thoughts around the regulatory environment for some of these new platforms.
And I was about to, just before I was about to say that, I think it was mentioned, I think in the earlier talk, I mean, there are certain countries out there that obviously are also not necessarily friendly to our national interests, but they have lax environmental standards, and that in the short haul can even give them a little bit of tactical and technological edge, because they can do things at a more accelerated pace than we do. And that's not to say that we drop the ball or we just chase our adversaries, but we have to figure out really how we are going to accelerate these developments while making sure that what we are doing is environmentally responsible and sustainable.
Just jumping in about regulation. So one of the topics that we think often about is regulatory risk, essentially. And this often comes down when we speak with investors. There's the entrepreneurs, but then who's going to actually fund this technology? Is it going to be the governments? Is it going to be the private sector? And one mechanism that many investors use when they're deciding whether to fund companies is to say, well, what are the different areas of risk that I have to encounter? The obvious one is technology risk. Can you build this thing that you think that you can build? Another is then market risk. If you build it, does anybody want it? But a third major risk for companies like ours, all of the companies that are in the room, is certification risk. Fine, let's say you build it. Let's say there's tremendous demand for it, but how long is it going to take to certify the thing? And that matters because it impacts the rate of return for an investor. Are you going to get your money back in 5 years, or is it now going to be 15 years because certification, it's going to take such a long time to get certification? Now, the FAA is doing an incredible job in this. They have an entire innovation center where they're focused on standardizing the certification pathway for new vehicles. And what that does is that then, once you have standardization of these pathways for certification, it reduces the risk, because now we know, now we can quantify it. Now we know about how long it'll take and about how much money it's going to cost. And the FAA has been doing incredible work in that space. And now what we're seeing is the DoD also leading the charge in that space, providing certification of new platforms. And so certification is crucial, not only because, obviously safety is number one and all of these things have to be safe, but when you think about mechanically how companies like ours are going to get from where we are today to getting to market, we need to convince a bunch of very conservative people to give us money, and certification is a main reason why they're not giving us money. So the more that we can quantify that risk, standardize that risk, and then reduce its impact on viability, the more that we're going to be able to accelerate these efforts. And the people in this room can do a lot to support that as well.
I just want to echo that. I think it's really incredible how FAA has responded to the onset of these industries in multiple. And a lot of even the vision to try to even pursue these new electrification platforms would have been infeasible, 20 or so years ago with the previous certification path available. So they're very much doing in a tremendous amount to adapt their thinking process for how they approach safety, resiliency, and a standard level performance, and trying to standardize that for a lot of these new vehicle platforms. So it is incredibly, it's good to see it all moving in the right direction. It really is, but there's a long way to go for sure.
Awesome. We have some questions from the audience, and Ian, I think this one probably is most appropriate for you. It's from Elise Joseph with Army Futures Command. Her question is really about, we've talked a lot about airplanes as a platform, but primarily Army aviation assets are rotary wing and unmanned aerial vehicles. So can you describe a little bit about what you see as Army benefits from electrification of those existing assets and platforms, or of moving those existing assets and platforms to electrified?
I think it's a fantastic question. So, of course, there are some limitations of electrification, but it's an application question. But these advantages and the opportunities are immense. I think logistically, from a amount of time that you have to be working on a thing to make sure it's working, that's a huge advantage. The cost of operating these electric vehicles is less than a third of what it might be for a traditional, internal combustion helicopter. And when you look at the complexity of these systems, there's a tremendous advantage at that, while having lower complexity, or at least mechanical complexity, but also higher resiliency and just a robustness to be able to interact with all sorts of unknown environments. I think that's a fantastic capability that's built into a lot of these electrified platforms. And then noise. Noise is really important. Noise is important in the commercial and the urban side of things, but it's also really important from the defense and the front side of things, where you don't want to have a large target, and it will affect your aircraft's survivability. This loudness of it, its presence in the field. So I think noise and being able to achieve low noise while still having the high performance, not only in hover lift efficiency, that thing that I was talking about, power, that thing that you need to get off the ground, but making sure that it's low enough so you don't need too much battery to be able to get that, but then also to have the performance to get into spaces really, really fast, faster than a lot of the traditional aviation or electric aviation companies have been targeting. But to really be able to provide that essential reduction in time to get there and get back. So.
And Jeff, I'm wondering thinking about some of the infrastructure requirements, and then thinking about the dual use application of, say, your platform and engine, and what are some of the opportunities that might be present in a remote or expeditionary environment with that kind of dual use application?
Yeah, absolutely. So I mentioned earlier that we're generating a megawatt class, or we're building, a megawatt class generator. One of the main uses is for fleet electrification. So if you think about today's generators, let's say amps, and you try to scale that up to the size of the megawatt class, which is what you would need for electric vehicles. So for example, today's amps, they're primarily used for HVAC, so for heating and cooling. They're used for electricity for a company of soldiers heading out into the field. But those things, those would never work for electric vehicles. You would need dozens and dozens of them daisy chained together. They would be extremely heavy, totally unwieldy. Just to give you a sense of scale, if you wanted to scale up amps, let's say a common generator that's used by the military today up to the megawatt class, it might weigh 50, 60, 75,000 pounds. To give you a sense of that, that's the entire payload of a semi-trailer. That's half of the payload of a C-17. So when you think about then the infrastructure requirements of all of the charging that will be necessary to enable fleet electrification, this is what Kyle mentioned earlier, today's generators just simply will not work. And so what we need is a new system. And so since our company, what we do is we build very, very lightweight megawatt class powertrains, it was natural that we would be able to transition that to building megawatt class ultra lightweight, ultra portable chargers, specifically to enable silent watch, silent mobility, and all the other benefits of fleet electrification.
And Marucci, you spent a lot of time, and Gabe, I want to get back to you, but Marucci, you spent a lot of time thinking about these applications and and particularly around contested environments. I'm wondering what your analysis and research shows, and what are some of the opportunities that are present?
Yeah, and I think back to that wonderful question also from the audience, in terms of the Army applications where there is a lot of, vertical lift platforms, and, and it goes back to the point as to, do we take the existing design and the existing airframe and retrofit it with electric power, or do we design from a clean white page, a new design, a new airframe that optimizes and takes advantage of these technologies. And I think both paths are viable. And and I think eventually, it will take time to develop those brand new vehicles that will be all electric from the word go. But in terms of the DoD use cases, there is, I think, it was mentioned that electrification brings the advantages of, obviously less moving parts, and so that it reduces the fatigue, and also we know that ultimately the maintenance that it requires and the downtime is low. But the big question in my head is really, how do we get the power to the vehicle fast enough? We cannot afford a 20-minute flight and the vehicle is offline getting itself recharged for 6 hours or 8 hours. I mean, that defeats the in a way that is not as compelling as I can probably even maintain my existing gasoline-powered vehicle, and so that I think is where the biggest impact will happen once we start being able to get power fast enough. There are concepts out there where maybe there's a bigger mothership, maybe using hydrogen power or something, and then have these smaller ISR platforms, maybe multi-rotor platforms or others that could, go and essentially dock or maybe have some faster charging to be done. And so there's a power supply in the air, so to speak. There are, and you can also look at grid concepts, but the other aspect for DoD is obviously security. Anytime you're talking about infrastructure, whether it's on the ground or in the air, I mean, that's also potentially a target for someone out there. And so you need to be able to secure them. Clearly, the noise reduction aspect is a benefit, but then there are other signatures out there. And also there are other security concerns that you need to take about because of the materials that you have on board, and they can present certain vulnerabilities, both in terms of availability, but also the technologies themselves could lend themselves towards those vulnerabilities that you need to. Yeah.
Thank you. And Gabe, I can tell you want to jump in on this, particularly around the refueling question, but I want you to combine it. I want to knock out two birds with one stone. Caleb Alexander from Daylight Batteries asks, what is the system level energy density that Zero Avia is getting with hydrogen? You answered that a little bit, but maybe reiterating and then talking about some of the applications.
Yeah, so to answer that question right now, we are at approximately 1 kilowatt per kilogram and 1 kilowatt hour per kilogram. Just happens to work out that way. And this is with essentially off-the-shelf, like automotive scale systems. This has not been really optimized to the extent that we want it to. So we have our technology roadmap, and we're looking at pushing probably to 2 to 2.5 kilowatts per kilogram over the next 5 years or so. And the energy density is largely constrained by the fuel tank, the composite overwrap vessel, so carbon fiber tank for gaseous. Currently at about the best of the best is about 12% gravimetric efficiency. There are some technologies on the table that look to push it up to about 18%. That's 50% improvement. And then cryo is really where it's at. I mean, this is what I was getting at before. That's upwards of tanks on spaceships are 60% plus gravimetric efficiency. So much better as we go. One thing I wanted to get back to on the original topic was the one thing you kind of get for free with any hydrogen electric vehicle is it's essentially a rolling or flying power supply. So if you have a multi-megawatt cargo aircraft, a C-130 or something, you have like a 2 megawatt hydrogen fuel supply just sitting there. As soon as it lands, you could plug in your M1 Abrams, you could plug in, whatever other high power systems you need and charge right from that aircraft or from your fuel cell powered Humvee or something like that. So you basically get high power electric charging as sort of a default capability with any hydrogen fuel cell powered vehicle. And then to touch on the last thing again, yeah, the the ability to transfer hydrogen as a fuel. So, battery, I love batteries. I fly battery electric airplanes, but charging takes a while. You need expensive DC to DC equipment. You need giant cables. You need, handling megawatts of power is super non-trivial. Hydrogen, I would actually go so far as to call it trivial to transfer that kind of power. It's literally just stainless cables and connectors and maybe a minimal bit of electrical negotiation. Keep an eye on some temperatures, but it's at the scale of the things we're talking about, it's trivial. And I think that is something that was brought up earlier. How to refuel your brigade of of equipment that needs to be refueled. And I don't think that there's any comparison between a fueled type system versus a battery type system.
And yeah, Gabe touched on this, but he was telling me about his commute, which involves electric aircraft in the San Francisco Bay Area. So if you want to ride, you can definitely ask him after. We have a question from Dean McGrew from the Ground Vehicle Systems Center asking about the thermal signature impact versus conventional systems. Has anyone looked at the thermal signature aspects of platforms and how they compare?
I mean, I can touch on that just quickly. So yeah, our low temperature PEM fuel cell operates under 95 Celsius. So exhaust temperature is at max, 90-ish Celsius, and usually less. And then the motors and inverters, 100 Celsius-ish. You kind of want to push them a little more for better delta T, gives you better efficiencies, but you could run them cooler. I fly an electric airplane, and when I land, the motor is frequently ambient. So it's, my airplane from a thermal signature is almost invisible.
Yeah, just to build on that, if you think of a typical jet engine, it's going to give off somewhere between 50 and 70% of the energy in the fuel in terms of, it's inefficient, so it's going to lose all of that, and essentially what that means is heat. So you're creating a huge thermal signature. The nice thing about electric systems is that they're much more efficient. So the megawatt class electric motor that we're building right now is over 95% efficient, pushing 97, 98% efficient. So you're just going to see a much lower heat signature because there's just a lot less heat being created. It's a much more efficient system. So just building on that topic, much better performance from that perspective, plus much lower noise as well.
I mean, I'm just going to echo, it's a different class, it's a different set of challenges, but the heat signature thing, I wouldn't say is one of the primary concerns for these vehicles. I mean, you do need to manage heat, especially in areas, let's say like Dubai, where higher temperatures may affect performance, but it's not a outward emission type of challenge, I don't think.
So yeah, thinking about how this sector is really going to move forward, what is one thing that you're really hopeful to see? What is one thing, whether it's for your company or whether it's the sector in general, one thing that is going to make you very optimistic, even or more optimistic about the future of electrified flight and sort of the broadening, I guess, of electrified flight?
Well, for me, I think certification, seeing the certification paths open up and seeing some of these early companies get through all of the necessary stages, so it's a graspable thing. You know the full shape of the whole process, because a lot of folks they're trying to figure it out, and we know, the 609 is still being, certified. So it is very exciting to see that, manifest. And develop our own processes based off of what we're seeing happen in industry. I think people adopting these things, people leaning in, is going to be very exciting. I know it's not going to happen on its own, which is why as an industry we need to reach out to communities and involve them and get their input and their contribution as well. So it's a lot of things coming together, but I'd say those are two very important factors.
Yeah, and just building on that point, I mean, it's the people in this room. If you look at what the Army is doing to convene this group of folks, and then as there is a transition to electric vehicles, the Army has about 250,000 vehicles. It's a huge customer of electrification, and that's just for ground vehicles. And then if you start to think about the movement of helicopters to electric and larger airplanes as well, it's going to be a major driving factor if the folks in this room continue to push it. And it's already happening, but they'll accelerate the efforts.
Yeah, Army's done a great job, I think, even with just the existing Joby and Beta platforms, giving them opportunity to fly and, you know, outside of FAA regulation. And I just look at, you know, projects that have been done in the past. SR-71 is always one that comes to mind, from nothing to, you know, world's most technologically advanced aircraft in 2 years. You know, so when the desire is there, when the need is there, and the government and our various forces decide they want to get something done, they get it done. And I think we're ripe for an opportunity like that in the electric space right now.
Yeah, and if I may just add to that, I think these are super exciting times, and I'm bullish about air mobility. You know, and also I don't see, truly speaking, a realization of the potential for air mobility without electrification, because that's what will allow for us to operate these devices in the urban environments safely and also cost effectively. And be reliable and provide you the number of trips that people can afford, right? I mean, at a price point that they can afford. Applaud the Army for championing and leading this cause. And what I would like to see, if at all, you know, is the Army taking the lead, but the DoD as a whole coming and setting up, you know, infrastructure challenge test fields across the nation, just like FAA has set up, you know, in terms of accelerating the certification processes for autonomy, so that they can become proving grounds, that the industry can come in and someone has a product or a solution or a technology that they want to test and also mature. It becomes a more of an open ecosystem that the Army presents the use cases and the challenges that they face, and the industry and other research entities can come in and shape that future. And I would love to see that as something that can accelerate this conversation.
Awesome. Well, I think we're going to leave it on that very optimistic and exciting note. Please join me in thanking our panel. Really tremendous conversation. And you guys will be here all week. So if you have questions about the future of electrified flight, here they are. All right. Thank you.
Thanks, guys. Thanks so much. Awesome. 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 Great job. Oh my gosh. Thanks, guys. Thanks so much. All right. I'm going to tell these guys what to do next here. Fantastic. Okay. Hey, everyone. I appreciate it. This is the kind of the very beginning here, first day. There's a lot on the next 2 days as well. And then this afternoon, there are a lot of things going on. So I'm going to give some information out, and so hopefully folks are paying attention. Last few hours of activity, right? We've got breakouts assigned for folks for today. If you're not in a breakout, please don't worry. There are things to do, okay? If you're not in a breakout this afternoon, you absolutely can hang here, co-work, get to know someone here. There's going to be quite a few folks that don't have a particular breakout today. Also, the 8th floor is open if you need a quieter space. There's a couple phone booths up there for like for a meeting if you need to take it. Obviously, Wi-Fi is available for you as well. But please, I think there's an opportunity here if you don't have a breakout to make your own discussion today. Also, on the first floor here from 3 to about 4:30, there's going to be a couple optional presentations here that folks can participate in from Small Business Office here at AFC, as well as Army Applications Lab and Capital Factory. There's going to be kind of a flurry of activity after I release you. So if you're looking on where you need to go from a breakout panel or breakout session standpoint, there's a couple Capital Factory staff right outside the doors here, And there's 3 breakout sessions on this floor. There's one on the 5th floor, and there's one on the 8th floor. We try to make it as complicated as possible for you. So hang in there. We'll make sure you get to where you're going. That starts at 2:30. And this kind of 30-minute break, you know, go to the bathroom, meet somebody, hang out for a second, do what you got to do. And then programming ends at 5:30 today, so there's no, we won't reconvene like this. But I will say a few words, let folks know, anyone that's hanging out in here, there is a networking social event that's entirely optional, but we'll be going on from 5:30 to 7:30 on the 8th floor tonight as well, some food and drinks, get a chance to meet some folks, have some further discussions. I think will be pretty fantastic to have a little bit less of a formal environment for. So that again, that's not Vertex programming, but that's available. So, okay, I'll let you all get after it. Thanks so much.